Good morning once again. Well, my partner in crime is here. It looks like we're not going to have a very good ride with this voice. For those of you who've never heard my voice, it's usually very honey. It's like honey. But today, it's as coarse as anything. Welcome to everyone. A special welcome as well to the guests that are online. We are starting the program now. We must apologize up front for two things. One, I've apologized for the voice that has deserted me. And number two, we must apologize for the late start. When it rains in Durban, we usually forget how to drive. I think it's a South African syndrome, but we will blame it on the weather, apart from other things. Today, we are hosting as DUT and DSTI, the 4th Space Science and CNS Symposium. This started 5 years ago. I was also an invitee in 2021 when we hosted the first symposium. And then I was already working for DUT in 2022, already participating in the Space Center. 2023, we didn't have one. That is why last year we had the 3rd Space Symposium. And we organized that. So you can see I've been moving up the ranks here. First of all, I was an outside invitee in 2021. 2022, I was already at DUT and working already for the CNS, sort of. And then 2023, I'm already up there organizing. This means in 2024, I should be sitting there. That is why the voice said, where are you going up there? Let me apologize for my colleagues. They refused to take the offer to come up here. But my steps are always led, so which means I'm not supposed to be up here. I'm supposed to be somewhere looking very important, sitting somewhere there. Okay, since we've started a bit late, we were going to finish a bit early. But 1 hour in South Africa usually means 1 hour, you know. So we started at 9, so we will be finishing before 4. Because what we will cut off are the wonderful bios that people have. I was going to read a bio for Prof. Ratilal, which would have taken about 7 minutes. So if we cut that out, it reduces everything to 7 seconds. So we've already saved 6 minutes and 53 seconds. We're gaining. So as a welcome and opening remarks, I would like to invite Prof. Ratilal, Sudesh Ratilal, who is the acting executive dean for the Faculty of Engineering and Built Environment. Prof. Ratilal, thank you. They are titivating him. I was doing very well in my 7 seconds. Now it seems to have been chowed.
Thank you very much, Program Director. Program Directors, thank you very much. Since you didn't read my bio, let me read it myself. Okay. Yeah, I think what Joe forgot to mention was that I am the outgoing acting executive dean until tomorrow. Yeah, so colleagues, welcome to this 4th, I'm going to say annual. I know we missed one, but I'm going to say annual because the intention is to have this annually. So 4th annual DSTI DUT Space Science and CNS Symposium. We've had very successful symposiums over the years, and I'm sure today will be no different. I know that the seats are looking a little bit empty, but I think the rain has really caused some havoc with us. And hopefully very soon we will see these seats filling up. So welcome to you, colleagues. I need to mention a few people, though. Mr. Moroka, I don't see him here, but I'm hoping that he will join us, hopefully, soon from DSTI. But in absentia, we appreciate the support that DSTI provides to the DUT Space Science Center. Professor Ojo, thank you very much, the director of the Space Science Center at DUT. I was going to mention Prof. Ramabodo, who's the incoming executive dean. He was with us this morning. He realized he had to run for another meeting. He's going to try and come back for the closing remarks, though, towards the end. And then there's some other people that I need to mention. Dr. Mazibuko. I'm not sure if Doctor is here. Good morning, Doctor. The CEO for South African Space Tech for Sustainable Development Foundation. Thank you very much for being here. Mr. Matsupola from Sensor. Not here, but we welcome him in absentia. Mr. Chikalaha from ATNS. Good morning, sir. Thank you very much for being here. Mr. Silver from UKZN. Thank you very much for being here. Yeah. So, colleagues, we welcome all our guests. We're looking forward to a very productive symposium. We've got 14, I think, technical presentations, and we're really looking forward to that. And I must say that these 14 presentations didn't come about just because we said we're going to have a symposium. I think there was lots of discussions beforehand, lots of collaborations that were happening. And we're hoping that this is not the end, because those talks and collaborations continue. So these presentations are going to spark some other interests as we move ahead. So as we're trying to save time, I'm going to hand over back to our program directors and say thank you very much. Let's hope that we have a very productive day today. Thank you very much. Thanks.
Thank you very much, Prof. I did not want to mention that he's the outgoing dean because he's still acting. This afternoon, I've got an approval that I want him to sign very quickly. So before he goes, he's going to commit another crime. I'm not implying you committed a crime. Well, I must apologize for Mr. Moroka. He would have loved to join us. However, he is, well, he's definitely not flying right now. He'll be flying tonight from the UK, back from another symposium that was taking place. But the acting chief director of the Space Science and Technology at DSTI, Mr. Itu Makoloi, is going to do a keynote address for us. He pulled my ear. You can see it's red a little bit. He said it's Makoloi, nothing else. So I'm not saying that other thing, Mr. Makoloi. Thank you very much. Okay, let's get you adjusted here. Yeah. Presentation. Yeah.
Yep. Good morning, ladies and gentlemen. I'm very short, but I guess even if you didn't bring it down, I would speak and probably you would hear my voice. Oh yes, I'm here representing the DSTI, and Kaiser gave me prepared a speech for me to speak. But program director, I think I'm for the idea of saving a few minutes. Maybe I'll save you another 8 minutes. And another 8 minutes, yeah. And so let me start now with what he prepared, and then I'll move away from it. He says, it goes like this. Good morning, ladies and gentlemen, Vice Chancellor, members of the academic staff, community, distinguished guests, sponsors, colleagues, and most importantly, students, researchers who are here gathered here today, who will be making their presentation. It is both an honor for me to come here to be here, on this fourth symposium of the Durban University of Technology. I believe these are events that really trigger, innovation, academic milestones. They trigger creativity, curiosity, and so forth. So to all the students that will be making their presentation here today, this is the reason why we gather. This is the reason that as the DSTI, we support events like this, partnerships like this, because exactly we have a mission, a strategy that we are following. And that strategy, basically, it comes from our national space strategy, where communication, navigation, and surveillance is one of the thematic areas that we speak about, or that is highlighted in that strategy. We also have other areas that we have, let me say, platforms that we've put in place. Community of practices in global navigation satellite systems, GNSS. And those are the issues where, people like yourself, we're inviting to be part of those communities of practices. And I don't have to sing. I'm not singing to the unconverted. Global navigation, communication is strategic capability for any country. In the geopolitical situations that we are in today, you step on the toe of a partner and he decides to switch off your systems, and you are cut off from whatever, the whole world. So those are the strategies that we saying as South Africa, we need to have these capabilities. But before that, we need the warm bodies, the experts, the expertise, and so forth. For example, one of the projects is in marine domain awareness, where we use the AIS systems to track, ships that are coming into our shores. Is surveillance. I believe that is communication, because fishing, illegal fishing is a problem. And then, of course, DUT was one of the identified institutions for the Pan-African University. And this thematic area specifically, we supported it because we wanted, this to actually be the center of excellence in that area. And then, of course, we have other partnerships with departments such as digital communication, DCDT, Department of Communication and Digital Technologies, to formulate a strategy, SETCOM strategy. And that strategy basically is one of the components is obviously navigation and positioning. This is the area that we are here. So we are glad to support the symposium, and I believe we will continue to support. And I'm hoping that everyone has good deliberations, particularly the students in their presentations. Remember that your work is part of a contribution to a much bigger picture. Program director, my job is done. Thank you. Thank you, ladies and gentlemen.
Thank you very much, Mr. Makoloyi. I have to be specific. I'd like to invite each and every one of you for a photo session, which will be taken in front here, and you'll be assisted by Mr. Ntuli. Thank you. Coordinated by Mr. Ntuli. Thank you.
Before you leave, who are we?
Abasad.
Oh,
We apologize. I'm so sorry. My name is Namhla Faith Mdukushe. We are your program directors for today. And next to me is Mr. Joe Lamini. I think due to his voice, he forgot to introduce us as the program directors. Thank you so much. Can we all move to the front? Thank you. Make our way to the front.
I hope your cameras do justice to our rather pretty faces. Thank you. Well, as we continue with the program, Mr. Cherry, we have an online presenter, that is Mr. Den Matsapula, who will be presenting online, representing SANSA, and he will be giving us remarks on the education that accelerate the education accelerators across the space value chain. We are going to connect him up and be able to hear him.
Can you hear me?
Loud and clear.
Okay.
It's just that we cannot see your sharing yet, but we can see something is happening. That's it. Hit play and you're good to go. Over to you, Mr. Matsapula.
All right. Thank you very much for the opportunity. It is my sincere hope that you can hear my voice, even though you cannot see my face. It is my pleasure to be presenting to you the SANSA Space Education Accelerators across the space value chain. Before I start, let me just greet my fellow classmate from 25 years ago at Stellenbosch University Satellite Engineering, Ndate Itumeleng Makoloyi, who's standing in for another classmate of ours, Ndate Keiza Moroka. At the risk of sounding like I'm singling them out, let me pass my greetings to my fellow entrepreneur, Ndate Thabani Mazibuko, and SANSA colleagues that are on site. I've seen a couple of them, engineers at the Space Engineering Division of SANSA. So, as introduced, my name is Dan Matsapola. So, I am the Space Education Manager at SANSA Earth Observation Division. I will start with our mandate because that's the genesis of everything. From the SANSA Act, provide for the promotion and use of space and cooperation in space-related activities, foster research in space science, advance scientific engineering through human capital, That's my actual focus right there. And support the creation of an environment conducive to industrial development in space technologies within the framework of national government policy. The vision of SANSA, which really has given birth to this new approach, the space education accelerators across the space value chain, accelerating space innovation for the advancement of all South African citizens and enabling global impact. That's a powerful vision. That's our 2025 to 2030 vision. And of course, our mission is to advance South Africa's national interests by leading and pioneering in space science and technology and innovation, transforming and supporting the growth of the space industry, collaborating globally to drive inclusive socio-economic development and a capable state. So SANSA's business is distributed across 4 divisions. So I'm currently at Earth observation, where we develop decision support tools. And a lot of this space innovation and space education accelerators are part of the decision making that individuals who participate in the space value chain must take into account to support the kind of decisions they make as they pursue career across the space value chain, hopefully a very rewarding career. Such as the one I've had in the last 24 to 25 years. Space engineering, which is where we develop systems that are destined for outer space to serve user needs on Earth. Space operations, which is where we are supporting the launch of rockets into space, where critical separation happens in our airspace that we are able to witness and collect telemetry that we provide as a service to the industry of rocket launches across the world. Hopefully, University of KwaZulu-Natal will soon be a client of ours from within. And of course, space science, which is where we are sitting with a 150 million kilometer laboratory, monitoring the sun and its activities that are influencing positively and negatively our near-Earth space environment, including technological systems on Earth. So, space innovation accelerators for human capital development, they are 4. Entrepreneurship, investing, financial literacy, and wealth creation. These are the accelerators that will help us to accelerate the rate at which we are developing both the systems, but this is focused on the people. Remember that, colleagues, let me remind you that the space value chain begins with human needs. The space value chain ends with human needs. So our impact statement is contributing to inclusive economic growth and industrialization, job creation, and a capable state through advancements in space science, engineering, and technology. So we have 6 strategic objectives at SANSA over the strategic plan Horizon 2025 to 2030. Increased space relevant knowledge that supports the developmental agenda. You've heard from the Ntate Makoloi's remarks. You can see already that these breathe life into the strategic intent that he alluded to, and the support that the biggest investor in the space industry, which is the Department of Science, Technology and Innovation, is making. Stimulated and growing inclusive space sector. Increased human capacity for the implementation of key space initiatives. That is my core focus area there, the human capital capability. And then SANSA positioned as a key enabler for the implementation of government space-related policies, enabling infrastructure developed and upgraded to support the space sector value chain, You may be aware of our assembly, integration, and test facility, among others, and the other capabilities we are developing in various districts of South Africa, Overberg being the capital district of space in South Africa. But we are seeing, with the moon exploration, we are seeing Fontaine coming up to support those lunar exploration missions from Central Karoo district. And so increased participation of the National Space Program in the regional and global space market. Those are the 6 strategic objectives. But now let me introduce you to the grand challenge of our ramp-up phase. We want to graduate our nation, and this is not something only SANSA is doing. Graduate our nation from being an emerging towards becoming an intermediate spacefaring nation. At the moment, all the spacefaring nations in Africa, none of them is in the intermediate spacefaring nation. We are Johnny come late to the party, despite our rich South African space heritage. Of course, we come from a very divided past, so it has not always been space for all. It has been space for some. But over the last 30 years, what we are seeing is that there is now inclusivity, and you've seen our impact statement there alluding to that. So as the Space Education Unit, what do? We stimulate multidisciplinary thinking through science and society engagement. And that is key to the accelerators that we've identified. We need to move into the era where we begin to bring in those from social sciences, the artists, from finance and economics and audit, because we need to run sustainable space businesses so that we meaningfully participate in the economy, particularly the previously disadvantaged. We support STEM education for the knowledge economy. We promote the innovative use of space science and technology by the youth and society. We develop awareness of career opportunities in space science and technology along the employee, business owner, self-employed, and investor model. So I'm showing you just a picture of what we actively do at our satellite ground station in Hartbeespoort, the most diverse satellite ground station on planet Earth in terms of commercial frequency bands, and it's in South Africa. Some of our platforms include direct school visits. We've done that with Dr. Thabani Mazibuko in KwaZulu-Natal, Zululand, various districts of KwaZulu-Natal. Career exhibitions across the 52 districts by 2030. That is the ramp-up phase target. We did 40 in the last 5 years. Now we are targeting all 52 districts. So we seek partnerships with DUT and other collaborators on the ground, particularly in the 11 districts of KwaZulu-Natal. Partnerships and collaborations, public engagement through media, and of course we leverage national system of innovation with NRF SASTA, of course, as the national coordinator of all science engagement in South Africa. And of course, through conferences like the one you've organized and communities of practice like the one in the National Earth Observation and Space Secretariat, we engage with various user communities. So our vision in the ramp-up phase in support of SANSA's big vision of accelerating space innovation is to produce 450,000 science, technology, engineering, and mathematics entrepreneurs, investors, and wealth creators by 2030. And we will leverage the maturity continuum from dependence to independence to interdependence in the STEM sector to deliver the full human capital capability. So a lot has been asked, what problem are we solving? You may be aware that our economy has not been optimally growing for over a decade. High unemployment in society and over-dependence by citizens on the government, looking at the government as the economic parent of the citizen. The words of a former president of the US come to mind there. Ask not what the government can do for you, but what you can do for and with the government. So we look at what DSTI is investing into the space sector as an investment, with an expectation that for every rand that is invested, we need to assure DSTI and the nation that return on investment at a rate of minimum 4 rand for every rand invested is the minimum the government and the people of South Africa should expect, because that is the ultimate shareholder of SANSA. So there is a script, and you being an academic institution, you are of course, a beneficiary of that script. Go to school, graduate, look for a good job with benefits, stay loyal until retirement, rely on your accumulated pension until you die. That's a script from the industrial age. It needs to die, that script, because it is responsible for much of what we are seeing in the form of high youth unemployment, because we, the elders who should be creating jobs for young people, are comfortable across the corporate ladder we don't own, and we are dependent on other people, and we remain perpetual dependent, regardless of whether we are in the C band where the normal scientists begin their careers, or D band managers where I am as a fat cat, or the F band of the CEO. The fact is that we remain perpetually dependent on our employers. That's why when we lose our jobs, we immediately look for another job, which doesn't solve the long-term problem. So globally, 3% of the population, of course, earn 97% of all the money earned, while 97% of the population share the remaining 3%. In South Africa, the current statistics are shocking. Only 235,000 individuals in South Africa earn 1.5 million rand or more per annum in 2025. That's 0.3% of the population. Too many Africans use the people at work strategy, few using the money at work strategy. So South Africa has a lot of lazy money that is not working. What are the accelerators that we've chosen? I've listed on the left-hand side the academic model: 7 years in primary, 5 years in secondary, and then, of course, tertiary education, which produces doctors like Masibuko and others. I remind these comrades and colleagues that their jobs are not their businesses, and we need to think innovatively and create wealth. So accelerator number 1 is wealth creation, which is a wealth creator is somebody who creates, preserves, grows, and enjoys wealth. And wealth is life in abundance, which means abundance in every area of life. Because we grow up in the poor side of social life, we aim to be financially abundant. And we forget that it is a whole wheel of life that we must look at. Accelerator number 2 is financial literacy, which there we show you Robert Kiyosaki's famous financial statement of the poor. On the left, financial statement of the middle class, who buy liabilities they think are assets that eat them alive. And then, of course, the financial statement on the right-hand side, which is the ideal financial statement, with assets putting money in our pocket, whether we work or not. A job only puts money in your pocket when you work. So accelerator number 3 is investing. And for me, there is only one growth rate, 5 divided by 0. It is infinite return on investment. I wish I could say to the DSTI, the 9 billion rand that you are allocating to your entities during 2025-2026 financial year is going to translate back into 90 billion rand in the economy through young people that are stimulated to think like the future Elon Musks and Strive Masiyiwas of the world, who are entrepreneurs creating value. beyond technical training, which Kaiser, Itumeleng, and myself, and I see my friend Takalani Chikalaha is also there from ATNS. We are all products of the Institute for Satellite and Software Application. I wish I could sit through to hear your presentation, but I guess I will rely on the recording if there is one afterwards. Accelerator number 4 is entrepreneurship. At SANSA, we are adapting it for internal purposes to also include intrapreneurship. Colleagues, employee, self-employed on the left-hand side, it's slow. We need fast acceleration, and entrepreneurship and investing are the fast accelerators of economic growth and space innovations. So this is just some notes I've made that there is a dominance of people at work, which means people are the slaves and money is the master. What we need more of to grow our economy is money at work, which means we use that M in STEM, mathematics, to actually minimize the growth and minimize the risks attendant on every enterprise and maximize the growth. We need to move away from dependence and grow into independence, and no amount of active income from a job will ever get us to be independent. And so I've already spoken at great length regarding a child in South Africa who is born. The most underutilized opportunity we have is the 0% income tax bracket, which is below 95,750 Rand. The average South African child by law at age 15 becomes economically active and joins the youth band. And of course, youth unemployment is very high. We need to think beyond go to school, get good grade, find a job, and be loyal. Final reflections. STEM entrepreneurs build assets that put money in their pockets, whether they work or not. That's what we need to inculcate, a mindset in primary school children. They need to have role models like Tabani Mazibuko, entrepreneurs in their own right, and who will stimulate them to think differently and entertain ideas that have never been entertained by generations before us. Governments all over the world are punishing employees with taxes and disallowed deductions. If you read on the DSTI website, there is a research and development tax incentive. Governments give incentives in things they want citizens to do. Employment, unfortunately, is not one of them. The only reason we get jobs is because we are programmed by those who raise us, who have jobs, that when we grow up, for us to drive the nice cars, live in nice houses, and dress as eloquently as Mr. Makoloi, we need to have jobs, whereas there is another way. So we need to flip the script. And the SANSA strategy converts getting paid once a month after tax into getting paid every day by solving Forex, something mathematicians are familiar with. Project implementation, of course, for the next 5 years, we are inculcating the entrepreneurial mindset in 13.5 million young people under Minister Gwahube, who are taught by 410,000 educators in 25,000 schools across the nation. This is $1 trillion rand market, and that is far cry from the 9 billion that DSTI is currently being allocated. So we need to communicate on how to unlock this market, because the laws have been written already. We don't need to change legislation. We just need to change the mindset of people, particularly in academia. We need academia to come to the party. Convert existing STEM graduates who are stuck in the corporate ladder from intern all the way to the CEO level in the F-band into STEM entrepreneurs, investors, and wealth creators. We are targeting DSTI entities, National Network of Science Centers, 26 universities, faculties of science and engineering particularly, because that's where STEM and graduates are coming out of. And according to National Development Plan, 450,000 of them must graduate every year. We must increase productivity of South Africa to reclaim the #1 spot in Africa. Egypt is challenging. Nigeria is breathing down our neck. If we continue down the path we are on, where we continue to program children to think about jobs, which are scarce, and we don't increase the absorptive capacity of the space industry, we are going to be in a bigger disaster by 2030. So we need to flip the script and change our ways. And of course, I think we stand a chance of being in the top 10 wealthiest nations in the world, with an exclusive economic zone, 1.5 million square kilometers surrounding our 1.2 million square kilometers of land. Imagine the rainbow nation of STEM entrepreneurs, investors, and wealth creators. We have 4 years to go, because 2025-2026 financial year is already gone. So with those remarks, ladies and gentlemen, let us solve the economic problem that we are facing, that is putting a lot of our population earning pittances in social grants, when minimum wage in South Africa, according to the tax laws, is 9,000 rand and above per month. So my name is Dan Matsapola, and I'm a STEM entrepreneur, investor, and wealth creator who happens to be employed at the Space Agency of Africa's most industrialized nation. Thank you for your attention, ladies and gentlemen. I will stop here.
I hope you can hear the clapping, Mr. Matsapola.
Unfortunately, I cannot hear them, but I take your word for it, Program Director.
They're actually standing. Mr. Matsapola, maybe Matsapola. Maybe there's some questions from the audience, which I will invite. But before I invite them, I'm concerned here, because the outgoing TVC, okay, the Vice Chancellor, Prof. Ratila, is saying he's leaving tomorrow, and I'm still earning less than 1.5 million rand. I'm sure he can commit that fraud one last time to increase my salary to 1.62. Well, I'm certainly above 9,000 rands a month, but I must confess, the lady that's working at home is definitely not earning 9,000 rands. Ladies and gentlemen, the session is being recorded, and Mr. Matsapola is gladly waiting for your questions, if any. Your hand, and then the microphone will rove to you. Well, I cannot really see, but it looks like, Mr. Matsapola, you were very clear in your presentation, unless there is one. Is there a question? There we go. A question is coming towards you, Mr. Matsapola.
Good afternoon, good morning, Mr. Matsapola.
Good morning, sir.
Yes. My name is Dozo Makwaza. I'm a first year at DUT. I am studying electronic engineering. And my first question to pose to you, sir, is rather than thinking, I see that you're presenting, or you're trying to present to us that rather than having to think or teach children to think in a traditional way, but to actually change the route and create actually create game changers is if I am correct. All right. I just also want to ask, how exactly would you market or try to change the youth sector exactly? Because the moment you mention it all starts with the youth itself, how would you go, or the company itself, how would you go about having to change the mindset of the youth?
Program Director, may I respond through you?
Yes, you may go ahead, Mr. Matsapola.
Thank you. That is a fantastic question there. Education, according to Sir Albert Einstein, is not just the learning of facts, but it is the training of the mind to think. It is safe to say, I hope I won't shock you, in the whole world, only 2% of the people think. 3% think that they think. I used to belong there too. 95% would rather die than think. The departure point is that every human has been programmed. I have been programmed. You speak isiZulu language, you've been programmed with that language. We have been programmed to think in a certain way, and there are settled ways of doing things that people are following mindlessly without thinking. One of them is getting to school and getting a job. We need to smash this systematic miseducation. So young people need to understand that their mandate on the planet is a business mandate. The word work is in the human mandate. Multiplication is in the human mandate. Perhaps that's why everybody should study science. Now, to change the mindset, we have to go deep and get back to the origins of the current prevailing mindset. Where does it come from? Why are we speaking English? We are colonies of some countries. So we used to be looked at as the people who must work for other people. Not, we must be consumers, not producers and originators of ideas. And therefore, we don't believe that our ideas are good enough. That's why very few people like Thabani Mazibuko write books. Why is it that you all went to school, you can write, but you don't write? It's because we have been programmed and we are conditioned to believe we are not worthy of becoming the entrepreneurs who will change the world. The biggest problem facing continent of Africa, the nation of South Africa, is the mindset of the citizens. That is the biggest problem. People don't think. We rely too much on the government, and of course politicians will ride that and promise you things they cannot give you. But 30 years later, I'm hoping that we are beginning to wake up as young people and realize that however much we love our politicians, none of them can put a single asset on your balance sheet, not a single income stream on your income statement. So start thinking for yourself, and it begins with understanding that you are God's highest form of creation, mandated to rule over Earth's resources, not to be a follower of other people's thoughts. You are to originate your own thoughts before you die. Otherwise, you are an intergenerational thief if you do not bring to us what God put inside you to deliver to the world in your lifetime. So it may sound like I'm very harsh, but I am simply saying to young people what Napoleon Hill said in 1937, think and grow rich, not work hard and grow rich.
There's clapping. There's clapping that Mr. Matupula. There's another question. I'm concerned though that there are 3 initials here. There's T, TT, and NT. Be very concerned if you are TT and NT. T are the thinkers, 2%. That's a concern. Think, Kagalani, Chigala, thinks, 3%. NT, non-thinkers, 95%. How is that even possible? I hope you can back up those statistics because I'm afraid I'm a lecturer at DUT. I'm not allowed to talk too much. There's another question for you, Miss.
Sepula, my name is Tabsile Kawunda. Thank you for a very nice talk and informative talk. But my question is, I wanted to find out if you guys are funding only schools, or you and universities, or you do also find like private companies, or if someone who wants to start their entrepreneurship with the technologies that they've learned?
Thank you for that question. You will notice that we are in what we call the ramp-up phase. And I know Justin Vitten is in the audience there. If you want to know what the ramp-up phase means, ask Justin. He knows all about it. We are supporting small, medium, and micro enterprises to start businesses. We have already done so with a program called Neo Frontiers. Can I be honest with you, my sister? You are not an entrepreneur until you know how to start a business for 0 rand, 0 cents. This is a challenge to everybody who thinks that they, or who aspires to become entrepreneurs. In my world, we start businesses for 0 rand and 0 cents. Funding is fantastic, but we know we are working with very limited resources in the system, in the national system of innovation. So while those who will be lucky to be funded will be given a head start, which is a launching pad for them to launch their entrepreneurial careers, ultimately, if you don't learn the skill, which is very, very rare entrepreneurial skill, to start a business with no money, despite economic management science teaching us that to start a business, you need capital. If you can grow beyond thinking of capital as only financial capital, and you understand that me knowing Thabani Mazibuko is capital, me having studied with Itumeleng Makoloi at 25 years ago at Stellenbosch represents capital. Me having traveled with Professor Ilchev to Russia some time back, around 2012, 13, 14, somewhere there. That represents capital. I can't speak a word of Russian, but I'm sure the professor can teach me a few things. Now, I'm saying that there is a lot of capital that we have access to. For goodness sake, a relationship with God represents capital. I'm a married man. A relationship with my wife represents capital. So capital is not just financial capital. There are many forms of capital. And if I was to invoke the laws of physics, I will say to you, in physics, we say energy can neither be created nor destroyed, but can be converted from one form to another. The skill of a physicist is the ability to convert energy in one form into energy in another form. Employees are converting time into money by trading their time for money. So when you are poor and all you have is attention, perhaps there are books that need to be read and a library that needs to be established in your house where you live, because authors have taken their time to put their multi-million rand ideas in books. But very few people read. Somebody said, if you want to hide something from a black man, and that refers to women too, put it in a book. They rarely read. Guys, let us flip the script. Let us have libraries in our homes and switch off that bloody TV that's stealing the wealth of our nation. So we support entrepreneurs. But I will tell you, from one entrepreneur to another, I'm an entrepreneur. I don't need anybody to give me money. I can use all the capital available at my disposal to convert that into as much money as I can. And no one can put a limit or a ceiling on how much money I earn, because I'm an entrepreneur par excellence. I've invested time, energy, mindset in myself. I encourage you young people studying at DUT to start investing in yourself. Warren Buffett, the wealthiest investor, said, investing in yourself is the best investment you can ever make. So if Itumeleng Makoloi gives you a few millions to spend on project A, B, or C, understand that that is a government that is investing in its strategic priorities. But you are an individual after that. When you leave DUT premises and you go to that flat, wherever you are renting or you are living, mind your own business, because I get paid to mind SANSA's business for 40 hours of my 168 hours week, leaving me with 128 hours to invest in whatever I choose as I pursue my path to financial freedom and financial independence first. So it's an whole educational experience. I wish I could spend time with you face to face, because I have been on this journey through the Institute for Satellite and Software Applications. Makoloi was my classmate. They wanted us to be entrepreneurs, but did not give us the tools. Today, I've made that word become flesh by realizing that there's no Messiah coming from somewhere else to rescue the black child. I am a Messiah within myself, and there is a Messiah in all of us. Passive income is the route to freedom. If you still love your job like I do, and you stay to help develop the next generation, we really welcome that. But many people, as soon as they are financially free, they resign from work, which means they hate what they are doing. They're only doing it because it pays once a month after tax. I hope you don't belong to that generation.
Thank you very much. They're clapping. If I had heard my voice, I would have called you Mr. Capital as your third name. I'm sure you've got a first and a second. So, Mr. Capital, thank you very much for a very nice motivational presentation and insight into how we need to live. Thank you very much. You may stay online, or
thank you very much. May I be excused? I thank you for the opportunity. I need to rush. I have another engagement with DSTI, the shareholder. And you know, we can't disappoint that one.
No.
Okay,
thank you very much.
So much.
We really appreciate your presentation and your presence. Ladies and gentlemen, that was Mr. Dan Capital Matsapola, and he's just acquired a new name. I'd like to call upon, before maybe I call upon Mr. Dr. Taban Mazibuko, I'd like to request Mr. Ntokozo Kumalo. Are you around? Mr. Ntokozo Kumalo, you'll be presenting at number 12 today to see Mr. Zulu at the back. Okay, I'm going to introduce Dr. Tabani Mazibuko, who's the CEO of South African Space Tech Foundation. He has been with us for some time as the DUT Space Science Center. He is a man that the capitalist, Capital Matsapola, has spoken about. So we know. Here's Mr. Capital number 2. Please welcome Dr. Mazibuko. And let's load your presentation. Sound. It's this one there. Yeah. So we're letting the queen assign.
Hey, Program Director, you committed a serious crime by giving Daniel Matsapula's speech before me. Eh? Matsapula, Daniel is paid to speak. So I know this guy can speak non-stop. We are blessed to have this guy in South Africa. Greetings, program directors, the acting dean, Professor Attila, DSTI, Ubaba Uitu Makoloi, SANSA, the king, Daniel Matsapula, CSIR, I see ATNS, Uputu Tagalane. I did not see SASTA, but they were part of this. And other valuable stakeholders and attendees. I also want to greet exclusively the director of the Space Center, Prof. Ojo, duty staff and committee, as well as all stakeholders who made this possible. Today, I want to use this symposium not to give presentation on a certain topic, but because I'm avoiding questions actually. I'm scared. I watch too much of Madlanga Commission and ad hoc committee, so questions and me are two different things these days. So I had a photo collage here to show the partnership. I also want to show students who are here that the symposium is not only for you to give the extras, to give us the proposals, but it is also an opportunity because your thesis and dissertations had recommendations and models that you propose that this is what we are going to do. These are solutions actually. So this is a symposium for solution. So today I want to show you, even if you went outside and maybe tried to implement that model and you failed, you must come back and tell us in this platform that, hey, this did not work. We are not going to deduct your marks. So I'm excited that this symposium is growing and we are beginning to see new partners in our banners. For me, it is an elevating to a level where it should not just be an event, but a platform for developing capacity, a platform for ideas and solutions, an avenue to attract investors and funding to space initiatives and means to fulfill all the 17 Sustainable Development Goals. Remember, South African Space Tech Foundation is trying to achieve our Sustainable Development Goals using space capabilities. This year, I witnessed these stakeholders moving our partnerships beyond boardrooms, but engaging with communities and schools to foster career development and spark interest in space science and innovation. KZN and South Africa, along with the rest of the continent, face numerous challenges that require effective solutions. Therefore, science, technology, and innovation remains integral to addressing various issues presented in our rapidly changing environment. Some of the these challenges confronting our country and beautiful province include water scarcity, electricity outages, climate crisis that leads to severe and frequent disasters. So to tackle these challenges, we need new inventions, technologies, and innovative solutions. We require accurate and real-time data for effective response systems and decision-making. So our goal was to extend our reach beyond the command line into outer space, which will enhance our capabilities in communication, navigation, surveillance, commonly referred to as GNSS, the Global Navigation System Satellite. Global Navigation Satellite Systems, so to say. This year, we visited, together with my partners here at DUT Space Center, together with USANSA, DSTI, ASRI, and other stakeholders, we visited more than 20 schools as part of this collaboration. I can't fail to note the role performed by this relationship with the DUT, where through Mr. Dlamini, they sent Ubabu Dlamini as a panelist to my book that was animated to film in Guamashu, demonstrating the clear orientation on the alignment of upstream and downstream space technology value chain. Today, we use visual reality to demonstrate how we use various technologies to educate our youngsters about space and other advances. You see, that is the VR that we use in different schools. So today, I think all of you will be in that VR and have a feeling to be inside the International Space Station and interact with astronauts. Today is the day. Executive Dean, in our last year's symposium, we announced that we will be introducing our second book, Life Beyond the Common Line. That was edited by Professor Martin Snow from SANSA, the solar physicist in Hermanus, who is originally from the University of Colorado. It is currently on display there at our exhibition booth, and within a month of publication, it was already available in various bookstores, including Exclusive Books. It was at different airports and malls of South Africa. We also promised to be using our collaboration with CSIR and NEOS to create disaster application to aid our KZN, which is frequently hit by catastrophes as a result of climate problems or crises. Despite the tardy response from user departments, but it has been delivered with success and it is installed in our cell phones. Director of Space Science Center, I must inform you that I was appointed by the KZN Premier to serve on his Climate Change and Sustainable Development Council this year. For me, this is a significant step in the right direction because that platform will allow us to establish a smart province capable of responding to a quickly changing world through research and innovation. That will increase our voice for support so we can use satellite communication, Earth observation, and satellite positioning to respond to these socio-economic challenges we are faced with. I'm trying to make us realize that it is our collective duty to solve problems and take control. We accompanied the SpaceX astronaut Dr. Sean Proctor to various Durban schools last year with the help of the Space Center and the US diplomatic general or the consular general. We need to use our space to inspire. That is one of the slogans she was chanting that day. So that is the nature of the partnership that we were trying to create with DUT. That not that when there's an astronaut, I would say, oh, I forget about you and I was with the astronaut, I forget to tell you guys that is not the type of the relationship that we are forging. The type of the relationship that we are forging is the collective relationship because I cannot solve this problem in isolation. I need to have partners. Our mandates are not similar. So no one is competing, but we are complementing each other. As a result, I urge you the responsibility of using offices and positions to influence decisions that will benefit this industry. Provide funding and hackathons for schools and villages. Establish space center constituencies and museums and provide space infrastructure, payloads, and associated capabilities. Let us sign MOAs for change rather than posing for pictures and photo shoots. I was pleased with the recent development where ASRI, UKZ ASRI is working with Mura Space to commercialize rocket launch facilities. This type of partnership we want to see from this symposium. I am looking forward to seeing how this will transform our local engineering, STEM education, advancement, research, and infrastructure investment that will fully leverage our socio-economic prospects for Africa space sector. I thank you.
Thank you very much, Dr. Mazibuko. I'd like to invite questions from the audience for Dr. Mazibuko. Dr. Mazibuko, I think you clarified your point. Is there any question online there, Cherry?
I intimidated them.
They're still thinking about 10. Yeah? Thank you very much. Ms. Mtugushe?
Thank you, Mr. Dlamini. I'd like to invite our first presenter, whose abstract is titled as follows: Integrating Machine Learning, Computation, Chemistry, and Experimental Design of Transition Metal Nitrates for Advanced Space Energy Storage Systems. Ms. Kaunda. Thank you.
Everyone, my name is Thabisile Kaunda, and I'm a PhD candidate in chemistry at the Durban University of Technology. So my presentation for today, as the director have already mentioned, is the integration of machine learning, computational chemistry, and experimental design for the transition metal nitrides for the advanced energy storage systems. So this is basically what I'm going to take you through, which is my table of content. And then the global challenge is because we have fossil fuels that is used primarily as the source of energy. So this causes a threat and is the major contributor of the greenhouse gas emission and carbon footprint. So when you look at figure 1, we're showing the examples of the sources of carbon footprint, which are your growing industrialization, your residential, aviation, and agricultural sectors. And those primary greenhouse gas emissions are basically your carbon dioxide, nitrous oxide, and methane gases. But there are more gases, it's just that those are the ones of priority. And then they are causing a huge environmental impact. And that is also shown on figure 1, where we can see that there's climate change, which is also affected by those fossil fuels and causing extreme weather events, which are your floods, your droughts, and storms. And some of that we have already seen here in Durban. And there's air pollution that affects the human health and the loss of biodiversity, which can harm the economy, because if there's soil degradation, then it means we cannot produce enough crops. So what does then, how does then the space is affected? The space is affected because of the accumulation of debris and the ozone layer depletion. And when we look at the next figure, which is figure 2, we can see that the scientists have thought about this and they decided that, okay, let us try to use clean energy. So clean energy sources is coming from hydropower, hydrogen energy, you have your solar energy, and also wind energy. So basically this take me into my research, where I decided to that I'll be making an electrode which will be used in a supercapacitor, which is some of the examples of the energy storage systems that are shown below. You have your batteries, you have your fuel cells, and your supercapacitors, which I'll discuss more. So now, how does chemistry fit in all of this? The chemistry fit in all of this because it is the it is the basis where we synthesize these materials that are used for space technologies. So these are some of the materials that are used for space technologies that are shown in figure 3. You have your Mars rovers that collect the information from the Mars, and you have your CUBE satellites, which are small satellites that are used for telecommunication and other various uses. Then you have your 3D printing and satellite constellations. So these material, they need to be light in weight, they need to be durable, and they also need to withstand different harsh conditions, including your extraterrestrial conditions. So coming to the energy storages, we've spoken about the battery. So the battery has high energy density and long-term stability, but now it has low power density and it cannot withstand high temperatures. Then you have your fuel cells, which are mostly used in spacecraft as power. So it supplies electricity in the spacecraft, and it also produces water that is used by the astronauts in the spacecraft. So this one is very good, but now the problem is that it is very expensive and it is difficult to store hydrogen. So then we have the third option, which is the supercapacitors. The supercapacitor, they have high power density, unlike the batteries. So they can charge fast. They have long cycle life. So it means that you can reuse them as many times, and they are very safe, but now with low energy density. So I've decided that I'll be creating a type of supercapacitor, which is a hybrid. A hybrid, you can see that on the types of supercapacitors that we have two mechanisms. It uses the electric double layer, which charges electrostatically, and the other one uses the pseudocapacitor that charges electronically, almost just like the battery, just that it's better than the battery. So the one that I'll be focusing on is the hybrid supercapacitor, because it possesses both the properties of the pseudocapacitor and the electric double layer capacitor. So our theme today, which is the fourth industrial revolution, how does it fit into this project? It's because I'll be using a material that is sustainable, which is waste. I'll be using waste to derive the activated carbon. And then it also uses the digital tools, which is machine learning and computational chemistry, to accelerate discovery, and also the nanotechnology. So coming to our literature, the supercapacitors already have been made before, but now they use carbon and metal oxide electrodes, which are good in performance, but now we've also mentioned that they have lower energy density. So this project will focus on using the hybrid to overcome that. And the transition metal nitrides are now currently under research because they are very abundant, and the fact that they are cheap and they are stable and they possess excellent electrical conductivity. So the 4 IR tools that we'll be using, as I've already mentioned, the machine learning, it has been used in prior studies, but now they have been using it as standalones, and it has not been integrated with experimental work. So the problem here that we're trying to address is that the energy storage devices, they lack sustainability, capacitance, and stability. And the fact that the conventional supercapacitors has low energy density and poor rate capability. So the nickel nitride that I'll be using to synthesize my material for the electrode, as I've already mentioned, its good properties, but now it is affected by agglomeration. So that is why we'll be using activated carbon that is derived from waste as a supporter. And it will also enhance the ion transport because of its porous structure. So machine learning will be used to predict and process the optimization and optimize the electrode. So this is the aim of the project. The aim is to develop a colloidal synthesis approach for the fabrication of nickel copper nitride and copper nitride hybrid nanocomposites and also test its performance to check its electrochemical properties. And the objective, the first one is to prepare the activated carbon using derived waste, and also to apply the colloidal in situ method now to prepare the nanocomposite material using my activated carbon and the nanoparticles that I would have made. And then we'll perform the DFT, which are your dental functional theory simulations, to analyze the electrical properties. I will furthermore explain when I'm discussing the methodology and also the machine learning techniques using artificial neural networks with MATLAB. And then after that, the electrode will be fabricated and tested using cyclic voltammetry, galvanostatic charge discharge, and electrostatic impedance spectroscopy. So this is the methodology that I'll be taking you through. So figure 5, we are seeing the preparation of the activated carbon. So the cabbage leaves will be obtained from English market in Durban and washed and dried, and then dried in an oven and then crushed into fine powder. After crushing, then it'll be treated with phosphoric acid and then activated in a muffle furnace between 350 to 600 degrees Celsius to obtain the activated carbon. Now, when we've obtained this activated carbon, it will be separated into 2 parts where we'll be making the copper nitride nanocomposites and also the nickel nitride nanocomposites. So they'll be made in 1-pot synthesis and in situ. So it means that we'll start by adding the activated carbon, and then we prepare the nanocomposites into the activated carbon using a 3-necked flask under those conditions, and the reaction will be kept at 110 degrees for 1 hour, and then after that it will be elevated to 260 degrees to now start producing those nanoparticles. So the precursor for the copper nitride, it is copper nitrates, trihydrates, and for the precursor for the nickel nitride is nickel nitrate hexahydrates. And then under the methodology, the characterization techniques that we'll be looking at is the TGA DSC, which checks the thermal stability and the decomposition of the material. And we'll also be looking at XRD, which confirms the structural crystallinity, and also the SAM, which checks the morphology of the material, and also TEM that will analyze the nanostructure, and it will also give us the exact size of the nanoparticles that are produced. BET will be used to measure the surface area and the porosity, and FTIR will determine the functional groups that are active, whilst the X-ray will determine the elementary composition and the oxidation states. In computational studies, we'll be using the Quantum Espresso software for the DFT studies, which will be used to investigate the electronic properties, charge distribution, bonding, your adsorption energies, mechanical and thermal stabilities. So this will be confirmed by calculating our density of stage, charge density, and surface energy, and checking those interactions between the nanoparticles and the carbon. And the molecular dynamics will now predict the transport mechanism that takes place between the nanocomposite material. So the machine learning will now be used as the input parameters that will be optimized using machine learning are your specific surface area, current density, voltage window, nanoparticle size, electrochemical conductivity, the annealing temperature, and the temperature of the of preparing your activated carbon. And the output parameters that will also be optimized using machine learning is specific capacitance, power density, electrical density, and cycle stability. So after all of this, the fabrication of the electrode will be used with the results that will be received from both the machine learning and the computational studies. So those results will now be used in order to fabricate that supercapacitor electrode. After the supercapacitor electrode has been fabricated, and then it will be tested now to see if what we actually predicted using the computational is exactly what we are getting when we are testing it physically at the lab. So that will be used by testing with cyclic voltammetry, which will test now the capacitance and charge storage. And we can compare with the ones that we have received from the machine learning if we're getting the same thing. And also the charge discharge to check the cyclability of the material, and also the energy density and power densities. And also the electronic impedance spectroscopy will be used to check the resistance and the ion mobility. So because I'm still at my proposal stage, these are the expected results. So from figure 8, we can see the pictures that are depiction of what Casey Tole did, which he was synthesizing the nanoparticles. And from the first picture, you can see those cubic small things, though, the copper nitrate nanoparticles that he synthesized. And at 15 minutes, he found the shape that they were cubic in shape, which were good for ion absorption. And then the second portion, it shows the range of the size of the nanoparticles, which were in very good size, because they're ranging from 25 nanometers to 55 nanometers. And the last one, we can see the slide show the FTIR results showing that indeed copper nitride was formed because of the peak that we can see at the end. I'm not sure if you can see it, between 1,000 to 500 per centimeter cubed. There is now a new peak that is formed on the last two pictures that was not there before. So what I'm expecting is that the material that I will use, it will produce high surface area and porosity and with uniform distribution. And this project is good for sustainability as it uses the waste, so it optimizes the waste in good use, and the activated carbon that is prepared is recyclable. And the electrode performance, because we are making an electrode for the hybrid, we're expecting to have high energy density, high power density, good cyclability. And with the computational and the artificial intelligence, we're expecting it to accelerate the material design, because we'll be using it to optimize most of the results instead of going to the lab and optimizing each and every parameter. So in conclusion, copper nitride and nickel nitride are looking as if they are promising material that can be used to make the supercapacitor electrode because of their electrochemical properties and the sustainability. And the nanomaterials are the future of sustainability and innovative material in the fourth industrial revolution. And this closed loop system, which involves the experimental, the computational, and the machine learning, will be the one that shows that the results are reliable. And the use of machine learning and computational chemistry is the one that we currently need now as it accelerates the material design. So the recommendations for my future work, I would like to possibly build a prototype and also be able to test it, and not just only a prototype for the electrode, but for the whole supercapacitor, and be able to test it at the space conditions that I mentioned below. So these are some of the references that I use for my studies. And I would like to thank my key partners, which is Space Science and Research Center and the University of the Witwatersrand that I'm currently working at to do my nanomaterial, and my collaborators from chemical engineering and electronic engineering. And thank you to my supervisors, Prof. Dina Dayalu, Prof. Moloto, Prof. Ojo, and Dr. Dede. Thank you for listening to me.
Thank you, Ms. Kaunda, for the interesting presentation. Do we have any questions for Ms. Kaunda? There's a question.
Thank you, Ms. Kaunda, for a wonderful presentation.
Thank you.
I just have two simple questions. First one, in terms of the capacity, you spoke about improving the capacity of your supercapacitors. I would like to know, compare with the existing one to the one that you're planning to do, how much is the capacitance, or rather the improvement that you're looking at, maybe in terms of the percentage or the capacitance, and also about the heating effect when it's being in application. Is it going to be better, like in terms of improvement? Because knowing the other capacitors, like electrolytic capacitors, they have the issues of heating and all those things which shorten the lifespan of the capacitor. What's your take on that with the one that you're planning?
All right, thank you for your questions. For now, I haven't decided on the capacitor, on the capacitance that I'll be working in terms of the percentages, in terms of how will it be better compared to the other capacitors that are there. But however, what my approach rather is to synthesize the material, and then from the material that are currently being used to follow those methods and synthesize it. And then after I've synthesized it, then there is where I'll be using the computational and the machine learning to now try to optimize and increase whatever that I got initially, which is based on what have been done previously, and then try and improve it from there, from the results that I will get. So at this stage, I don't have the exact percentage that I will say, okay, it will improve by this percentage, but I'm hoping that with everything that I've encountered that will overcome the challenges that we are currently facing, I'm hoping that it will improve. Okay, and once I've done it, I will let you know. Okay, thank you.
Question?
Can you go to your first slide, please? Thank you for the good, nice presentation. Second one, the one where we start dealing with methodology.
This one.
Yeah, I just want to see, I don't know if I'm wrong, is that cabbage at the beginning?
Yes, I said the cabbage leaves.
Okay. If that is your, I assume it's your raw material.
Yes.
Okay, if that is the raw material, how do you reconcile meeting SDG 2, 1 and 2, which are no poverty and no hunger, because you're going in a territory where we need cabbage. And then you say you're gonna use it for batteries. Can you tell us if during your studies you will do a trade-off between actually using this raw material, which is still needed to achieve your other goals, which are other sustainable. Thank you very much.
Okay, thank you. No, what I'll be using, I won't be using the whole cabbage, but I'll be using the cabbage leaves at the market, I went there. There are like so many cabbage leaves that are being thrown away, and they're like a whole bunch. So instead of letting all that material go to waste, then I'll be using it, but I won't be affecting any. No. No. Thank you.
Thank you, Ms. Kaunda. We hope to see some of those results from your prototype, hopefully, in our 5th symposium next year. Our next presenter is Ms. Mokoena, whose abstract is titled The Conceptualized Space-Based Solar Power Plant. As Ms. Mokoena is coming on stage, I'd like to remind you that we do have a QR code where you can scan to have access to the program. Thank you.
Maybe take just 1 minute to give our DUT gift, the DUT way, to Mr. Makoloi. Prof. Ratila, may I request your presence? Thank you. You may leave it. I will gladly keep it for you. That's why I'm keeping it. Cherry, what happened to the lights?
Greetings, everyone. Greetings, everyone. My name is Londiwe Mokoena, and I'm a master's candidate at the Department of Electrical Power Engineering. Today, I'm going to be presenting my research on the topic, the conceptualized space-based solar power plant. Now, this is mainly a review on, it's one of my topic of interest, space-based solar power. So this is mainly just a review on the development of these concepts thus far. So the world's growing demand and needs for sustainable and uninterrupted energy continues to place enormous pressure on our conventional power systems. And as we already have looked into many renewable energy sources, which are terrestrial, such as your wind and solar. These resources are contributing greatly towards greenhouse reduction. However, they remain constrained by factors such as your weather conditions and time of day and geography. This is why this is what brings us to the exploration of space-based solar power. Now, space-based solar power promises to be an energy source which is available 24/7, is not affected by weather conditions, and is not even affected by the geography. So the concept of space-based solar power is mainly based on a simple idea, which is collecting power from an area where it is most abundant and transferring it to an area that it is mostly needed, which is Earth. This research aligns with the United Nations Development Goals, number 7 for clean energy, and then number 13 for climate action. Now, space-based solar power dates back to the 1960s when Dr. Peter proposed the solar beaming, or proposed satellite beaming solar energy from space towards Earth via microwaves. Since then, there's been a growing interest on this concept, as different organizations such as your NASA and JAXA continue to provide, to conduct experiments and continuous research, which have brought this concept from being just a theoretical concept to an ongoing and soon to be feasible renewable engineering energy technology. So the system of space-based solar power, as shown on the figure, mainly works on 3 stages. It has 3 stages of operation, whereby the first stage is the energy collection stage, which occurs on the satellites which are located on the geostationary orbit. So the collection mirrors, as you see, that pentagon shaped mirror thingy is the collection mirror, which absorbs sunlight or solar radiation, and then focuses it towards the PV arrays or the PV cells, which are those blue round shaped thingies on the sides. So the PV cells then use that radiation energy to produce DC power, which it then sends to microwave or laser generators, which are also embedded on this satellite system. The second stage is the the energy transmission stage, whereby this microwave or laser is then transmitted wirelessly towards Earth, towards the Earth-based receiving stations, which are called the antennas. Now, on the final stage, which is the energy reception stage, which occurs on the ground receiving antennas or antennas, is the stage where the antennas collects this energy in the form of microwave or laser, and then uses it to create usable DC power, which it then sends towards our grid. So the most important parts of our space-based solar power design is the choice of solar array design. Now, different array designs have been proposed for space operational concepts. We have your Z-folded solar array, which has been successfully used on missions like your International Space Station Now, this solar array is, as I've said, it has been successfully used before. It is, however, heavy and costly to launch. And then we have our fan-shaped solar array, which is designed such that it is more compact and it is not as heavy. And however, it has the disadvantages of not being able to produce enormous power, which would require in a space-based solar power plant. So it is mostly used or preferred for exploration missions. And then the most favorable solar array design is the rollers fan or the rollers array, which is made of thin film PV material that's automatically unrolls. So it can be transported as a rolled array, and then making it easier for transportation purposes or for launch purposes. So it can be rolled towards space and then gets unrolled there. And these designs have achieved excellent power to mass ratio, exceeding 75 watts per kilogram, which is reducing launch cost and enhancing their deployability for large-scale space-based solar power applications. Now, we have two ways in which the solar power can be transmitted wirelessly towards Earth. We have your microwave transmission, which uses a frequency ranging from 1 to 10 gigahertz. Now, this transmission method is more efficient over long distances, and it has passed many experimental tests. However, it requires large ground antennas and requires higher power density regulations in order to ensure safety of human and wildlife. We also have your laser transmission, which operates on the infrared and visible light spectrum. Now, this transmission allows for precise and narrow transmission, which requires much smaller antennas. However, this one poses much more danger towards human life and requires greater pointing accuracy and is more preferred for short ranges, such as your interspace or intersatellite power transfer. Now, looking at the design the design of the antennas, which is the ground rectifying antennas. This rectifying antenna is responsible for converting the transmitted power, which is in the form of microwave or laser, and converting it into DC reusable power. Now, these antennas are designed such that they have the first components being the antenna, which collects the microwave energy and then converts it to high frequency AC current or alternating current, which is then sent towards the low pass filter all the way to the Scotchy Barrett diodes, which acts as a rectifier, converting this high efficiency alternating current into your pulsating direct current. Now, the pulsating direct current is then passed through a filter capacitor, which then filters its elements and then combine them to form a high voltage direct current, which is then passed towards the system inverter or the power inverter, which then inverts it to alternating current, which is compatible for grid conditions, and then it is finally fed towards the grid. Now, besides looking at the engineering parts of this concept, we must also consider the environmental concepts or the environmental factors. So this concept offers nearly zero greenhouse emissions and requires minimal land footprint, even though the antennas require some space in the ground. And however, there are risks associated with it, which include its possibility to contribute towards the space debris and the need for controlled beam safety and the rectangular land uses I've mentioned. And economically, this system is costly as the satellite launching can be quite expensive. However, the inventions of the reusable rockets have however, decreased the cost, which were our major economic barrier, making this concept more economically feasible than it was before. And this concept requires global cooperation. As you know, we could be setting or sending or launching one of our satellites to space. Another person in some other country could be doing the same thing, and then they collide, causing more danger or problems than we need. So global global cooperation is required in order for this to succeed. And some global cooperation rules that have been implemented before that we could maybe match is the 1960s Outer Treaty. There should also be global energy space framework, which will ensure that the launches are safe, flexible, and are deployed equitably. No. Okay. No. I'm not considering it. Yes, I'm sorry. Okay. It is important to note that space-based solar power is not meant to replace the terrestrial renewable energy sources. However, it is meant to complement them and stabilize them by ensuring that it provides it acts as an energy source that is freely available throughout the time, and when those other terrestrial renewables are unable, like during night times and so on. By providing a base load power unaffected by weather nights, space weather or nighttime cycles, space-based solar power could feed national grids, support remote regions, and power future lunar and Matthias habitats. Now, the integration of these concepts with existing systems could enable dynamic load balancing, improving the energy resilience in both developing and developed countries. Now, space-based solar power is a transformative path to sustainable global energy, and its realization depends on collaborations among different countries or global collaboration and sustainable policies to ensure that technical, financial, and regulatory barriers are overcome. With the right global framework, space-based solar power could evolve into a cornerstone that's not only harnesses sun's limited energy, but also symbolizes our collective commitment to a cleaner and more equitable future. These are the references that I've used to collect this research or to connect this research. And I would like to give my greatest thanks to the spaceman, to the to the Space Science Center at the DUT. Thank you.
Thank you for the nice presentation. May we invite some questions, please? Is that Dr. Lochi? Oh, Dr. Lochi, you have a question? Just 1 second, Dr. Lochi.
Ms. Mukwena, my question is about the reusable rocket.
Yes.
How are they related to the current project?
The reusable rockets.
And what are they first, and how are they impacting on the cost, like you said, for
Okay.
this project?
Thank you for your question. The reusable rockets are meant for delivering or transporting the equipment towards space or to space, as the whole satellite system cannot be transported as a whole. There's gotta be different parts that need to be individually transported to be combined when they are already in space. So those are the purposes. So initially the rockets, since they were used once or single use, it was more expensive. So now they can be, as the name says, reusable. One rocket can be used many times, thus decreasing the cost. However, I haven't really looked deeply into the design of those rockets. I will try to look into them and understand more about them as going forward. Thank you.
And another maybe follow-up question. Are there existing systems currently?
Currently,
Or will this be the first one?
Currently, there's no existing system. There are still experimental projects on this type of system. There hasn't been any actual system built so far.
Thank you.
Thank you.
Thank you, Dr. Lochi. I think we have another question from Dr. Shange.
Okay, thank you. I heard you speak about space debris due to launching of this equipment. Can you elaborate on that? And you mentioned that this technology is not to replace the terrestrial PV system, but to collaborate it or to enhance it. Can you expatiate on how that can be achieved? Thank you.
Okay. The space debris is the waste material or waste material that are found in space. So in instances whereby there's a launch that is being sent to space, and this material, such as maybe there's a panel that is out of use or defects, this panel, like space debris is merely unused material that is just sitting in space. So in cases whereby the system is launched into space and fails, it could somehow be an unused system that is just sitting there in space, causing space pollution. So space debris is mainly space pollution. Can you please repeat your second question?
The impact of your technology over because you said it's not to replace, so how is it coming to, how do you mean it's going to enhance the terrestrial system?
Okay. Thank you for that question again. This concept is meant to enhance the existing, it is meant to be integrated into the existing system. So this concept can be actually the power or the laser, the microwave, the microwaves can be sent to different parts of the different receiving stations. In that way, by not focusing it towards one station and sending it to different station, we could send small bits of power to different receiving antennas, ensuring that it mitigates the need that is left by the existing terrestrial energy sources. That way, it doesn't become the main source. However, it adds towards the need that is left by the remaining or the readily available systems. So that is how it is meant to stabilize, but not to replace the existing systems or networks.
Dr. Lucci, we want to have tea now. We're very thirsty.
Thank you. No, I just wanted to add an advantage on the system. If we have one system that is fixed on the ground, then we only have power during the time that that part of Earth is facing the sun. But with your system, anytime the sun energy can be collected, if one part is going to be missing the sun, but the energy will still be available and can be sent to another part of the world, making the world grid more sustainable than putting small stations everywhere. That is how I look at it, and I think I picked it up from your presentation.
Yes.
Thank you very much.
Thank you.
Well, it looks like there are no more questions. Your misery is over. Thank you very much. Jerry, we have a problem here. I saw a spider here. Now there's a spider web all over this place. Ladies and gentlemen, we will do which means luck. It's based. Okay. Right. We will change the program slightly due to our late start. Most of us are tea lovers, coffee lovers, cappuccino lovers, doctored tea. Would like to take this opportunity to use this time for tea break outside, and then we'll also have the exhibitions so that we can have a chance to go into that virtual reality station and other exhibitions as well. I would like us to return to the venue at 11:35. Thank you very much, ladies and gentlemen. Mrs. Pillay will now give a presentation. Mrs. Pillay is from the Department of Electronic and Computer Engineering. She is also part of the Space Science and Research Center, and she will be giving us a presentation on what the Space Center is busy with at the moment. Thank you very much. I didn't tell you about the spiders.
Good day. Thank you, Program Director. And good day to colleagues, students, members of the Science and Technology, DSTI, SANSA, ATNS. Thank you for affording me the opportunity for making this presentation. As Mr. Dlamini indicated, I recently joined the Space Science Center at DUT as a project coordinator. So this presentation is focused on our very first project that we embarked on, which is the autonomous Mars rover. So a little bit of introduction to why we perhaps chose this project. Exploring distant planets has long piqued the interest of scientists and engineers and even curious students. So successful missions by real-life rovers that are used in NASA's Mars missions, such as Perseverance and Curiosity, were the inspiration for this project. So the intention was to bring the same level of exploration and innovation to a local hands-on environment. The main aim was to design and build an autonomous rover that can navigate outdoor terrain, collect environmental data, and physically interact with its surroundings while being remotely monitored and controlled. So it represents a real-world industrial application. Similar autonomous devices are used in agriculture to analyze soil, monitor crops, and collect environmental data. And in environmental science, robots like this one play an important role by entering locations that are dangerous for humans. Some of the key areas of research that are included in robotics, wireless communication, vision, navigation, and renewable energy. We are aiming to achieve some of the SDG goals, such as SDGs 9, 7, and 17 with this research project. So some of the key features of this autonomous rover, it will have a robotic arm, which will be used for measuring soil moisture, monitoring air quality, and even collecting small samples. It will use onboard intelligence system, a navigation system, which will make real-time decisions to navigate obstacles, modify its direction, and complete tasks without any human intervention. To enhance the autonomy, the rover will be powered by a battery system, supplemented by solar panels, allowing it to recharge and remain operational for long-term outdoor use. So some of the key specifications obviously are the power supply. We are opting for a 24-volt lithium-ion battery, which will power all of the major electronic systems. The solar charging system will consist of 2 solar panels, 10-watt modules for efficient power distribution, and these are fed to a solar charge controller. And then we have the control system. At the moment, we are using the Arduino Mega, which is used for controlling the hardware, such as the motors, the servo motors, actuators, and sensors. We're using an ESP32 module, which is providing the Wi-Fi connection and allowing the rover to transmit and receive commands via a web dashboard, which is hosted using a Raspberry Pi. We are using the ESP32 camera, which handles the image capture and live video streaming for visual data accessibility in real time. And this ESP32 camera supports environmental observations, functions including litter detection, vegetation monitoring, and general terrain assessment through the web interface. We also have a dashboard, a unique dashboard, which manages the control and live status updates, including the ability to switch between manual and autonomous modes. For the navigation and the movement, we have 4 DC motors coupled via L298N motor drive, which provides the wheel drive system for the rough terrain. We have ultrasonic sensors, 4 of them, which are placed on 4 sides of our chassis to detect the any obstacles and collision avoidance. For the environmental sensing, we chose to consider many options. One would be the soil moisture sensor, which would measure the soil moisture by detecting capacitance changes caused by varying water content. Then we have a temperature and humidity sensor, which measures the ambient temperature and humidity. We've also included a gas sensor and the light detector. Then we have the robotic arm. We are using a MG996R. This was a prototype, so this was the first one that we are using. We may consider upgrading, but this is metal gear servo motors that power the robotic arm. It has 6 degrees of freedom, and it collects the samples and deploys the soil moisture sensor for analysis. So this is the block diagram. As you can see, all of the inputs on your left-hand side, which are all the sensors that I've mentioned going into the Arduino Mega, and then we have the ESP32 Wi-Fi module. with the motors, drivers for the wheelbase and the chassis, and the robotic arm with the web dashboard. So essentially, this is our project. So just to give you an idea, the 3D modeling design, I mean, on the left is the Mars rover. So initially, our first consideration was the one in the middle, which is the single solar panel design. And then the one on the right-hand side is for the 2 solar panel design. So we are still at the process of finalizing which one we are going to go with. But this is the 3D modeling so far. Some prototyping pictures, because we have started prototyping it. So our chassis is using a 2mm aluminum plate, which is rigid enough to support the weight of the robotic arm and the electronics and the battery and the sensors, etc. And so they on the right, if you can see on the left-hand side, we kind of gauging the height requirement we needed, the height clearance between the chassis and the solar panels. So that was just a little bit of pictures here and some more pictures here of our diligent students and staff members that are involved in the project as we were integrating our prototype. So the progress so far with the project is that we have completed the planning stages, the design and validation. We have tested the components, as in the sensors were individually tested to confirm their functionality. We are currently busy with the system integration and functional testing, as well as the data dashboard and data logging review. So, you know, if you have a moment, you can have a look at the first table as you in the next hall there, or as you exit. Zanele is one of our students that has been very much involved with the integration of the project, and she will show you how far along we are with the prototype at the moment. The wheelbase design and integration is still to be determined, but we are leaning towards the similar design for the NASA's Mars Curiosity with 6 wheels, 3 on either side of the chassis. And then obviously, once we have integrated the wheelbase design and confirmed the full system integration, then we will take it out into the field for trials, and we can present those results later on. So some future projects for the Space Science Center that we are looking into considering going forward, perhaps adding an UHF antenna design to the rover itself, the nanosatellite project, mini space habitat with AI assistance, and an Lever radio telescope, and a space weather station. So these are possible projects which we will still continue with our students and our staff members at the center. Just want to take a moment to acknowledge our team leader, Prof. Ojo, for your faith in our team, our sponsors, in particular the DSTI, for this financial support, Ms. Ngobo and Mr. Eslamini for the administrative support, Ms. Zanele Sitolo for her many long hours and commitment towards this project and the integration, Mr. Mahai, Mr. Masinga, Mr. Jules, and Ms. Makanya for their technical support, and Mr. Mabaso, who is one of our alumni mechanical engineering students that assisted us with the 3D designing of the rover, and any and all other colleagues and students at the Space Science Center that I may have not mentioned here, please forgive me, but we appreciate your input and your support with regards to any projects that we are developing in the Space Science Center. Some references there, and that's me. Thank you so much for your time.
Thank you, Mrs. Blake. I'm sure there are a few questions.
I disappeared.
We've got an attack from spiders.
Yes, I can see that. No question.
Oh, thank you very much. There are no questions. Dr. Luchi, you wanted to ask a question?
Of course. I'll feel left out. I'll feel left out.
Before Dr. Luchi, we've got a question at the back.
Yes. Can't see.
That's Dr. Masibugo.
Okay, thank you so much. I'm very, very happy with this because for quite some time we've been communicating with Prof. Ojo and Prof. Ratilal that at least we need to have a prototype as DUT, because if you look at different universities that have something, I can count from Stellenbosch to ASRI here next to us. But my word was that if we have an organization that is launching rockets without payloads, that is good as no effort made. But now that we are having something of this nature, it will create our own footprint now and identity as a DUT Space Center. So I'm happy with that. But because now I sit to the Climate Change Council and I see these winning different hackathons, but I want you to look at different elements to make it the one. I'm currently working with other guys from Felixton College in Empangeni that are exhibiting that as one African hackathons using Mars rover. But now I heard that you are still going to decide whether it is going to use solar or whatsoever. I said, please, let's use solar because it will appeal to this global climate change elements. And I wish, because this is the Mars rover, not just a car or a toy. One stage, if we want to align it with other organizations that are launching, it needs to move like a real rover, Mars rover that went and ejected its what is that? That small Ingenuity helicopter. So we need to have other team that is good in robotics and coding that will align it so that when it goes up, it can eject itself and come down and be able to land in different and not natural surfaces. So I think let us take that route so that it can be a global appealing prototype. Thank you.
Yes. Thank you. Thank you so much for that comment. Definitely, that is something we're going to look at, to include and upgrade on the project and build upon the project. And we can definitely focus our efforts on those key points that you mentioned. Thank you.
Thanks. My question has been taken by the previous.
Thank you very much.
Thank you.
Thank you very much.
Thank you very much, Mrs. Pillay.
Thank you.
Oh, I'm not sure, Tanya. It looks like there's still a question there for you, Mrs. Pillay.
Okay. Thank you for the nice presentation. My question is about the solar panels. So I'm asking how you are going to maintain them, because I can imagine some dust collecting over time. I'm not sure if you touched on that, but.
Thank you for the question. So, in fact, that was the dilemma about whether we should use a solar panel or not, because we know that the Mars rovers on Mars, the environment is very dusty. So this is why the Mars rovers don't have solar panels, so that is the challenge we will have to look at. Perhaps that'll be another research area, another way of us maintaining to keep the dust off the solar panels. We can look at either fan-based integration or some kind of a brush sweeping mechanism. So that's something definitely we are looking at. It's on our file folder as additional add-ons, perhaps, to look at that. Thank you for that question.
Well, perhaps the next speaker.
Yes, go for it.
I don't know if you've touched on how it works. Maybe I've missed it. I don't know. But the solar panels, what do they do actually on that? Is it the car or something? I don't know. What's the name?
Oh, there we go. You killed me. No, so we said that we were going to use a 24-volt lithium battery to power the electronics. The solar panels will be as a backup to be able to recharge the battery. So, we're going to still look into that. We still haven't spec'd it fully, based on what our servo motors are that we need for the wheels. We are looking at the moment at 10mm wheels. So we also want it to be, we don't want it to be too slow, but we also want it to not be too fast, because the terrain that it would probably drive will be, that will determine basically what our requirement is for the solar panels and the charge controllers. So we will look into that still.
Okay, is it not affected by the weight?
By the
weight?
By the weight.
Yeah.
Well, that's the whole idea. At the moment, we calculated the weight load for our current prototype, and we're looking at around 8 kilograms. Yeah, so that will then inform our wheelbase and the requirements for the wheels that we need.
Okay, thank you so much.
Thank you. But any input towards the project, if anyone is interested to get involved in it, there were a lot of interesting questions, please contact us. We are looking for students especially to get involved in something interesting and something concrete that can represent the Space Science Center.
And get funding.
Just go to drop us an email, I'm sure. It's obviously to be part of the Space Science Center. I'm marketing now for the Space Science Center, but it's a volunteer. It's on a volunteer basis. So we do have students that are doing honors like in electronic engineering or mechanical engineering, but then they are also doing projects and involved in projects at the Space Science Center that are space related.
Sorry, it looks like I have too many predictions.
It means it's interesting.
I'm just interested to know if you allow someone, for instance, the topic maybe that will be covered, it will be the part of maybe the project, but it's not really in space science. For instance, if maybe I'm working on the solar PV and maybe the batteries charging and things like that, of which it's something that can be used, but not directly. So can I be the part of the center or not?
Okay, I'm going to hand over to Prof.
All right, thank you.
Okay, thank you very much. I knew I'm going to be the one to answer this question. I knew from the beginning. As I said, you can take the question to me. To answer your question is very easy. Space science is multidisciplinary. It's not specific to any discipline. I will mention it that we have project as far as management science. What I'm just trying to say is that anything you do is space science. Energy storage, electronics, robotics, what's it called? Tourism. In short, anything you are doing must have an application in space science, meaning that you are 100% welcome. Anything you just thought of now will be applicable to space science. Thank you very much.
Thank you so much, Prof.
Thank you very much for all the interesting questions. After the next speaker, I will be handing over to my sister here, co-director, to direct the rest of the show. But before I do, I'm going to invite Mr. Tagalani Chikalaha, who works for ATNS, Air Traffic and Navigation Services, as a senior researcher there. He is here because he's the man who is responsible for all the research, not for all the problems that take place at ATNS, but for all the research that is going to help solve the problems that are there at ATNS now and in the future. Now, to answer one of the questions about getting the dust off the solar panels, when we built this airport, King Shaka International Airport, have you ever seen someone hanging out the windows, cleaning the windows at that control tower? No, because we used glass called self-cleaning glass. Mr. Chigala may tell us more about that, but I'm not going to put him on the spotlight. There is self-cleaning glass that can be used where dust does not settle, depending on the type of material that you use, but it's something that should be interesting to us as space scientists. Mr. Chigala, please join us to give us your presentation on GNSS. Thank you. GNSS.
Good morning, or still good morning or afternoon. Thank you, Program Director. As he said, my name is Takarani Chikara. I'm a researcher at ATNS, at Traffic and Navigation Services. The program you will see that there's a keynote and GNSS monitoring. So I requested that maybe I should provide the presentation on GNSS monitoring. Before I start with my presentation, Joe is right. We don't clean our glasses at the control tower. Those who know the tower where our air traffic controller sits, you'll find that they are somewhere up there. So if we have to clean them, it will require a lot of work, starting from the supply chain to get the company to come up with it will be very difficult and to clean those windows. Hence, we use those special glasses. And the other thing, again, on a lighter note, it's not good to give your cell phone to program director, because every time he will send you a message to say, hey, please don't waste my time. So I did mistake to give Mr. Jamini my contact, but that's just on my lighter note. I'm going to present the GNSS monitoring system. This will be the outline of my presentation. As I've said, I got the message to say I shouldn't go through all the slides. So some of the slides, I'll just give them just a brief and then pass to another slides and so on, just to save time. I know everyone is looking forward for lunch, so I have to make sure that I save time. So this slide, it shows the system supply chain for ATNS. So if you want to know ATNS, this slide, it will give you the overview of what we do. We provide air traffic management. So for us to provide air traffic management, we need systems that will help us to communicate, navigate the aircraft from the departing to the destination. So we use different systems. As you can see, we use communication, we use navigation, we use surveillance system. And most of those systems, they are terrestrial systems, which means we have to go and survey somewhere in the mountain to put the communication tower, or to go somewhere in the mountain to put the radar, and so on and so on. So we are happy because the technology is changing. We are moving now to space-based technology, and this is where GNSS is coming in. So as we plan for the future, as an ATNS, we come up with the project to monitor the GNSS signal. That is to ensure that we are confident enough that the signal that we are getting from the satellite to our system to aircraft is reliable, is safe, is accurate, and is continuously. If you are moving from Durban to Johannesburg, we should have a continuous signal connected to aircraft until you reach Johannesburg. So hence we have to do this GNSS monitoring. So in our supply value chain, you'll find that the aircraft will depart from the airport. it has to communicate with the air traffic controller. In this case, instead of using surveillance on terrestrial network, we used to move to satellite network. And then I'll skip some of the introduction, but what is important in this slide is that in 2023, the industry come together to develop what we call the National Air Navigation Strategy. The purpose of that is to ensure that we align as an industry. So in the sub-working group, we have the representative from different industry, DSI, DUT, SANSA, CSIR, South Africa Weather Services, and so on, just to make sure that as we come up with the plan for future, we have all the requirements, the input, also the support from the airline, so that we can provide the services. And then I'll come to the objectives of GNSS monitoring study. As I've indicated, that we are planning for the future. So we need to analyze the GNSS key performance indicators that I will talk about them later in this slide presentation. We need to evaluate the signal performance at our airports, and we also need to assess the interdependency among those 4 key performance indicators. And then we also need to study the impact of weather on the GNSS signal, and also to provide the recommendation for GNSS monitoring augmentation improvement. So those are the main objectives for GNSS monitoring study. This slide talks about the background of GNSS in aviation. And then we understand as an aviation industry that GNSS is a backbone for our air navigation and also for precision landing of the aircraft at the airport. And then we also understand that for that to happen, we need to have an accuracy and reliability to ensure that we are ready for safe flight operation. And there are 3 different types of augmentation system under GNSS. We've got the satellite-based augmentation system. We also have the ground-based augmentation system and the Airbus aircraft-based augmentation system. So all these augmentation system, we use them, or they are future technology for aviation industry. However, they provide different services and they've got different capabilities. For example, if we talk about aircraft-based augmentation system, they use satellite, but there's no need for us as ATNS to play any role there, because it's the communication between aircraft and satellite. And then if we talk about the S-bus, yes, we have a role to play there to ensure that we provide the air traffic services in our industry. However, it also has its own drawback. For example, if we have to meet the precision landing for Cat 2, the system doesn't have that capabilities. So which means we have to look further than S-bus. Then that does take us to ground-based augmentation system as one of the systems that we need to consider as an aviation industry. So to make sure that we are confident enough that this system will work, we have gone as far as installing the GNSS receiver in our major airports. This to make sure that we monitor the satellite signal around the airport and also in an in-route. And then also what we did, we installed the multi-frequency receiver, taking into consideration that we have got different satellite constellation. We have got the Galileo, we've got Beidou, we've got GPS and so on and so on. So we wanted to make sure that we monitor the signal from all the satellite constellations. And we also wanted to ensure that there's a consistent tracking of signal for analysis. So every month we wanted to provide the report as to whether the coverage in terms of satellite is good enough for us to move from terrestrial network to space-based network. And then the figure there shows the GNSS monitoring network, whereby we've got the receiver that we're going to use to collect data from the satellite. And then we are going to connect that with our internal network. And then using our internal network, then we will connect it to our central monitoring system. This is whereby we can be able to read and understand the impact of weather condition, and also to understand the impact of ionospheric model or ionospheric towards the GNSS signal as to how it affects the GNSS signal quality. So we are going to get the data from the receiver. Of course, we are going to store it, we analyze it, and then we determine whether we are happy in terms of the key performance indicators, which is continuity, availability, accuracy, and reliabilities. And the main important for us to measure those signals is to ensure that the GNSS signal is available all the time, and also to ensure that the signal's threshold is more than 99%. Because if it goes below 99%, so we considered that signal as not good enough for us to provide our services. So which means we'll need to make sure that there's a continuous signal availability along the en route when the aircraft is flying. And the other thing that we need to consider or to check is the integrity of the system. Under integrity, we need to make sure that the safety index is less than 1. So if we measure anything that is above 1, so we consider that signal not strong enough for us to use it for air traffic management services. We also make sure that we measure the accuracy, and then the minimum requirement is less than 220 meters. So if we are monitoring the GNSS signal, check the accuracy, we need to make sure that it's less than 220 meters for non-precious precision approach. And the other thing is to measure the continuity of the signal, which means that the more we've got satellite covering our airspace, the more we are going to get the continuity. However, these KPIs are being affected by weather conditions. This way we need to check if it's raining, how the signal is affected by the rain, the storm, and so on and so on. And then the graph there is some of the data that we have collected from different airports. And then we analyze them. And as a part of analysis, we also check the impact or the interdependency of the KPIs, or GNSS KPIs. For an example, if the signal availability is strong or is weak, how does that affect the continuity or the accuracy? So from the data that we collected, we need to make sure that we analyze to see the interdependency of those KPIs. So these are some of the graphs. And then you will see that if, let's say, for an example, we take availability and the continuity, you'll find that somewhere, somehow, availability doesn't necessarily mean that there will be a continuity because of the signal degradation, because of the weather condition. But I'll go more into details in the next slides. So in this slide, it shows the interdependency between different KPIs. We've got availability and accuracy. And if we have to compare the availability and accuracy, we realize that the high satellite availability enhances the position, but does not ensure accuracy due to atmospheric and multipath effect. And again, under the satellite integrity and reliability, we have realized that maintaining integrity ensure availability signal are reliable, preventing the incorrect positioning even with a high availabilities. Under continuity and integrity, we have found out that continuity ensure uninterrupted reception supported by integrity check to avoid navigation error in our environment. And again, under accuracy and continuity, we found that it's continuous but inaccurate data is unsafe. I'll also go into details for this based on the data that we have collected. So as I have said, we installed those receivers at our airport. So this analysis is based on the data that we collected in 2022, between 2022 and 2023. We generate different reports from different sites, and then we analyze those reports. We integrated the weather data in our analysis, and then we got those weather data from the timeanddate.com. And then from there, we analyze the data, the signal availability, the continuity. When we talk about the signal availability and continuity, we realize that there's a drop during the springs and summer, which means that the signal degrade in terms of weather condition, more especially in the springs and summer. And we also realize that higher temperature, humidity, rainfall affect the signal qualities. Hence, then we need to develop the atmospheric threat model to correct these errors. I believe this is where SANSA come in, where they can be able to assist us. And then we also realize that atmospheric disturbance and multi-effect also degrade the reliability. So if we cannot guarantee the reliability of the signal, so which means that it will be unsafe for us to use that particular system to provide the air traffic services. And then based on the data that we collected, we have found that thunderstorms and severe weather reduces the availability of GNSS signal. In this case, we can't be able to rely on that particular system to provide the air traffic services. And then, as I've said, ionospheric or tropospheric disturbance reduces the accuracy. And then the multipath effect reduces the integrity. And again, the heavy rain and snow reduces the continuity. So hence it's very, very important that we continue to measure this so that we can guarantee the services. Otherwise, until we get confident enough that we can use this particular signal system, GNSS system, then we will continue to use our terrestrial system. The key finding based on our study, we have found that GNSS key performance indicators are strongly interdependent, as I've indicated. Weather and ionospheric activities significantly influence the performance of the GNSS signal, and also signal degradation observed in warmer humidity sessions. Yeah. And then again, the integrity risk rise when the multipath interference and the poor continuity. And then in conclusion from our studies, we have realized and noted that we need to continue doing the GNSS monitoring, and this is critical for our aviation safety. And then system performance must be tracked across all the KPIs. Weather mitigation and integrity assurance are the key to reliability of our system. And again, when we are implementing S-bus and G-bus system, it will require a robust ionospheric model to ensure signal reliability in the aviation safety. And I believe that SANSA, they can come on board and assist us to develop that ionospheric modeling in our airspace. Thank you so much.
Thank you, Mr. Chigalaha. May I invite questions from the audience, please?
Okay, just a quick question. I would like to understand what make you to design the GNS system instead of using the current system that are available.
Okay. As an organization, we need to plan for the future. And we understand that the future is on space. And then we also believe that for us putting the terrestrial infrastructure, it's very, very expensive. So for that reason, so we plan to introduce the space system or the space network in our environment. Hence, we do this performance monitoring to ensure that when the time comes, we are ready and we've got enough data to confirm that the system will work, and that will be to ensure that there is safety in our airspace. But the biggest reason is that technology is moving, and we need to move with technology. As the new aircraft are coming with the new technology, we need to make sure that we are also ready in our airspace to accommodate those new aircraft with different capabilities. And again, we have realized that by introducing this new technology, it will also help us to put more aircraft in our airspace, also to manage departure, to manage arrival, and so on and so on. So that's the reason we are considering the space-based technology, or GNSS.
Okay, please. I'm actually referring to the space system, monitoring system, not the terrestrial one. So the current one, existing space monitoring system, what is the drawback of the current one for you to start thinking about designing the new system? I'm not referring for the terrestrial one. I'm saying about the space one, please.
Oh, maybe I didn't understand your question correctly. You are saying what is the problem with our existing system?
The space one, monitoring system. Oh, it's not existing.
So we don't have, okay, we are not using a GNSS system currently. We are mostly relied on the terrestrial infrastructure.
Okay, I get now. Thank
so
you.
we are planning for the future.
Thank you.
Yeah.
Dr. Luchi.
Oh, okay. Thanks. I think in the morning I was so knocked out by the first presenter, the one online, that I didn't have anything to say. I was, and even now I'm still thinking of what he was mentioning. I mean, the dependence to the systems of other people. I'm going to share a small reality that we are living now with renewable energies. We went to visit one of the companies that is manufacturing solar systems. And I posed them the question about the inverter, just the inverter that we see everywhere. They say that technology is only controlled by Chinese. And actually Chinese are able to get into any inverter in the world in terms of communication, because all are becoming, with technology, they are becoming digital with internet controlled and so on. Indeed, they can come. Meaning, if they decide, for instance, to switch off a plant in Africa by rendering the inverters inoperational, they can do that. This is how sensitive, and I don't know if we are aware of that. Yes, we are aware because we're talking about it. When I go up with I'm in an aircraft, I'm in a plane, I always think of that. How much of technology in terms of these aircraft, how much control do we have? How much control your system, does it have? Are we going to buy equipment from them and then say that we are safe, we are controlling the space, while we are not actually in control? Another small example, the machines that we use for printing. Minolta, the company that is making them, I don't know if the management knows about that. They can actually make them to not operate, especially if you don't pay them. So I'm just trying to raise an awareness and also being worried about what direction are we giving to our researchers. Do we want to take control, or do we want, like you said, to keep on following technology? And up to when? What are the risks? Thank you.
Thank you, Prof. Actually, you raised a very important point. that I was discussing with Kaiser and George Hamini when we were in China last 3 weeks back, to say China's are selling us all these technologies. They are showing us the capabilities of their technologies and so on. And as such, they are targeting African market as a way to compete with other European, Americans, and so on and so on. So the question would be, do we have to buy into their system, or we should, as a country, consider doing our own thing? And that reminds me to the time whereby Ukraine, you all are aware that Ukraine is fighting with Russia. There was a time that Elon Musk was threatening them to switch off their internet connectivity, depending who pays more and so on and so on. So the question is, as South Africa, do we really have to rely in other people's technology, whereby they can decide to switch it off and we realize that we cannot provide the services? I believe that as a recommendation maybe, is this need to start at the academic level, the universities. They need to come up with the research to develop these new technologies. Of course, when we are developing this technology, we need to understand the trends as to where the technology is going. How can we make sure that we develop our own technology? We understand our requirement, we understand our environment. What stops us? Maybe someone might say, we don't have funds, but the question is, what have you done to make sure that you get the funds? I believe DSI, through Technology Innovation Agency, they make funds available for people who want to come up with the new system and so on and so on. For example, currently we are working with CSIR to develop our own radar that uses the frequency modulation, the frequency signal for radio to navigate or as a way of surveillance system in our environment. And we have to go as far as to source the funds from Technology Innovation Agency. So the question would be, what university is doing? As a lecturer, what are you encouraging the student to do? As an industry, what are we doing to make sure that we influence the development of this technology? I understand that sometimes we need to have agreement in place, because other companies, they might say, yes, we are willing to assist, we are willing to provide funds, but we need to have some share of some sort. Can be in the terms of intellectual properties and so on and so on. But I believe we need to do something. I might not have necessarily have the correct answer, but that's my thought. I think we need to start either at the university level and so on. We need to collaborate with the industry to understand their requirement, to understand their challenges, and then we develop this technology on our own. Thanks.
Thank you very much, Mr. Chikalaha. We will be with you shortly in terms of handing over the gifts for ATNS in return for gifts towards the Space Center. Mr. Chikalaha, it looks like we have another question.
Thank you so much for a presentation. I just wanted to find out that in development of this system, did you consider putting measures in place in order to protect it from cyber attacks?
Okay. It's a very good question as well. Maybe I should clarify something to say, for now, we don't have the system. What we have done is to install the receivers that can be able to receive the signal from the satellites. Of course, we collect the data, store it in our servers. To prevent the cyber attack, of course, we need to protect them. You will find that most of our network, the network that we use to control our aircraft, is not connected to the outer world. It's an only internal network. Maybe let me try to say it's an internal network. But that doesn't mean that we cannot attack, because it might be attacked through the email. You send me an email, and then with whatever attachment, I open that attachment, then it affects our internal network somehow. But it's very, very important that as an organization, actually we have the policy to manage the cyber attack. And every time we let our employee to go through the training to be aware of these cyber attacks and so on and so on. And with the measures to what they need to do if they receive the email that they might suspect that it has got some sort of virus or cyber attack and so on and so on. So we have the internal policies that manage that. But our network is not connected to the outer network, the one that we use to manage the air traffic system, the communication network, the navigation network, and the surveillance network. Thank you.
Thank you very much, Mr. Chair.
The were difficult.
You'll have more lunch. Thank you very much, Mr. Chigalaha, for representing ATNS. Remember, I'll be giving a report to ATNS pretty soon about how you did here. We do not seem to have Mr. Massing on the line there, Cherry. In which case, I'll hand over to my sister here.
Thank you. This is perfect. Our next presenter is Ms. Mangala, who will be presenting a study called Wildfire Assessment Using Remotely Censored Data over Mpumalanga. Thank you.
Greetings, everyone. I am Olona Mangala, the first author of the work I am to present here, which is part of my MSc study titled Wildfire Assessment Using Remotely Sensed Data over Mpumalanga, a province in South Africa. So this is just like the guide of the presentation. I'm going to give a bit of an introduction and a motivation of the study, some literature review, problem statement, the aims and objectives, methodology followed by results, and the conclusion. Wildfires have long made it to the list of environmental disasters that are experienced worldwide. Our own continent, the African continent, has experienced like significant wildfire activity such that it has been labeled the fire continent. And again, our own country, South Africa, has experienced some devastating fire events. And the analysis of wildfire activity has marked its strongest footprints in the Mpumalanga province. And particularly in the year 2007, the Mpumalanga province experienced some worst fire events. If you look at the figure here on this slide, these are classification maps of some dominant land cover classes in the Mpumalanga province. The forest, some water bodies, cropland, build-ups, the barland, and the other vegetation class that consists of some shrubs, grasslands, and some other undefined vegetation covers. Now, we classified these land cover classes for 3 years, 2006, that is the year before the fire events of 2007, which was now the year of high fire activity, and also for 2008, that is after now the fires. Now, I think we're just looking, I'm not sure if you can see my figures clearly, but some of the dominant changes here is the degradation of the forest class. You see, moving from 2006 to 2007, you can see the difference now on the forest class, and going now from 2007 to 2008, and now there's even more pronounced degradation in the forest class. And other changes include now the other vegetation class, which is said consists of some shrubs, grasslands, and other undefined vegetation covers, taking over what was earlier classified as an area that consisted of a cropland. Now, these significant changes emphasize the significance of looking into the fire events of 2007 in the Mpumalanga province. Some literature has looked into the study of wildfires, looking at different aspects in the topic of wildfires, but they still remain a great environmental disaster. A study that is more similar to the work that we are doing here was conducted 10 years ago that looked in the whole South Africa. Now, it was a spatio-temporal analysis of fires in the whole South Africa over an 11-year period. And this is one of the studies that marked the Mpumalanga province as one of South African provinces that experienced high fire frequencies. And again, one important finding that they came to was that the air temperature was associated with the fire events in that period. And also several other studies have also came to a conclusion that the drought or the dry periods were behind some fire events. Just one example is devastating fire event of 2017, the Naisna fire of 2017. The fire erupted just after some observation of dry conditions that were depicted by the vegetation. On the problem statement, a considerable body of studies have looked into the investigation of fires, but the predominant focus was on the savanna ecosystems and the grasslands. Now, the investigation on these specific ecosystems give us the some valuable insights now about the behavior of fires, the frequency, some ecological consequences, but also focusing on just these specific ecosystems has created now a gap in understanding of some specific fire events occurred in specific regions of various land use and topography. But well, I don't really cover the topography on on this presentation. Okay, then on the aims and objectives, we're looking at we map the spatio-temporal distributions of banning in the Mpumalanga province. That is now to analyze the fire regimes of 2007 in the Mpumalanga province, and again look at the correlation of the occurrence of fires and some climatic parameters. And the parameters that we're looking at, meteorological parameters, is the surface wind speed, the precipitation rate, and the land surface temperature. And also, again, we look at the aerosol, at the impact on the aerosol emissions of wildfires. Then, yeah, I've already mentioned that the study area is the Mpumalanga province, and I have tried to tap in on the result or on the reason of choosing and the Mpumalanga province as our study area. This is the second smallest province in South Africa, spanning an area of around 76,500 square kilometers, which is a home to 3 biomes: the savanna biome, the grassland, and the forest biomes. Sorry. Okay, the study follows a correlation-based design such that we are looking at the occurrence of fires, and then we want to know how the climatic parameters affected that occurrence of fires, and again the correlation with the land cover change that is after fires, and also the impact on the aerosol emissions. Okay, now for the figure on my very first slide, the introduction, that classification map, that is, those are classification maps, and for that we used the random forest training model to do the classification using the Landsat 5 dataset. So yeah, it's quite a process that involved, the very early stages involved defining those classes. You saw the classes that I had there: a forest, built up, spellland, and etc. So we defined those on the satellite image, then we input those on the code that we actually use to do the classification. Okay, maybe I won't explain more on that. Then now for the climatic parameters, the wind speed and the precipitation rate, we download the data that is readily available there on the Giovanni NASA's web app. Both the time series trends and the map data are there. Then we download the data and do the time series trends on the Python programming, and for the spatial maps we use the QGIS. Yeah, that's what we did for most of the, because you'll be seeing my results here. I have most of some time series trends and the spatial maps. Okay, now getting on the results. The first thing here, I try to give that spatio-temporal analysis of fires of 2007 in the Mpumalanga province. Figure 3 here is the monthly spatial distributions of burn days. It gives the monthly sequence of burning in the Mpumalanga province, which I hope you can see here that we have some. If you look at the months July, August, and September, this is in figure 3 of 2007, we had most burning pixels. Oh, okay. Here, what I actually present here it's a map of the burning pixels. That is the data. It's band area data using the band date layer, and it represents the band pixels. That is for each day of the month. It maps where it maps where a positive band pixel was recorded or detected. So we see that we have most of these band pixels mapped in July, August, and September. And yeah, I'm sure that is very expected because that coincides with the winter season in the Mpumalanga province, which is a dry season. So we expect like a lot of burning taking place at that time. Then on the left, I have the temporal now trend, which quantifies now the bent areas and give like monthly averages of the bent areas. Then on the next slide here, I have now my parameters, the surface wind speed, precipitation rate, and the land surface temperature. And yeah, I'm sorry, I think I may have like missed left out some important like results on my slides, but here because I think it would have been good to show the correlation values, because I worked out the correlation values between the burning, that is the burnt area, and each of these parameters here, and the correlation between the wind speed and the burning, it achieved like a strong positive correlation of 0.5. Yeah, let me say 0.5. And then as you can see from figures 4A, 4B, and 4C, like, and also look at the figure here of the bent area in figure 2, like from the physical perspective, you can already see that for the wind speed, there's positive correlation. Then for the other two, the precipitation rate and the land surface temperature, there's negative correlation. And yes, the Pearson correlation coefficients confirmed these getting negative, okay, and a moderate negative for the precipitation rate and a weak negative for the land surface temperature. Then now coming to the spatial maps, the two figures here, 4D and 4E, these kind of contradict what we observe on the temporal analysis, because like I said, you can see from the figures that there's a positive correlation between the wind speed and the band area now in the temporal variations. But now looking at the spatial variations, if you look here at figure 3, you can just look at any of the months, July or August or September, where we have like most of these band pixels. You can see we have like our band pixels concentrated somewhere in our study area, and that covers 4 districts in the Mpumalanga province. Then you come here now and look at figure 4D. You see that the very same areas that had highest fire activity, they have the lowest wind speeds. So now this kind of contradicts what we get from the temporal variations. The same thing with the precipitation rate. From the temporal variations, we see that we get the lowest precipitation rate for the periods of high bent areas. But here, for the periods with the highest bent areas or largest bent areas, we observe highest precipitation rates. Then now with the LST, yeah, the results from temporal variations and the spatial maps do agree. Okay. Now, maybe to try and explain on these results that are kind of contradicting, then obviously we expect the wind speed to exacerbate the wildfire occurrences. But again, we have wildfires in the areas that have like forests, and the density of this forest will now decrease the wind speeds, which now will make the same areas experiencing like high fire activity, or which are more vulnerable, also having like low wind speeds. But yes, the wind speeds like from around still exacerbate fires and also influence the burning in these areas. Then now with the precipitation rate, again, if these areas are experiencing like high precipitation rate, now in the long run, when the dry season comes, okay, now the rain will increase the flammable fuel on these forests. Then now when the dry season comes, there will be more fuel than these, while they are actually experiencing high precipitation, but they'll still experience high fire activity when the fire season comes. Then yeah, I think there's not much to explain here on the land surface temperature, but because the land surface temperature, there's a weak correlation with the band area, and this is said to have a secondary effect on that is the land surface temperature has a secondary effect on the burning. That is, it is not really a cause behind the burning, but it is an indicator of the dry, cold conditions which accommodate the fire occurrence. Then lastly, I just give like a brief overview on the emissions, looking only at the aerosol optical depth and the angstrom exponent, which are the optical like properties of aerosols. I just zoomed in now into this specific fire event of 2007 and mapped the aerosol, spatial aerosol before the fire event and a week after the fire event. And you can see the red block here. I'm trying like to focus on the increased AOD and angstrom exponent values or variations after the fire event. Yeah. Oh, okay, now in trying to conclude on all that I was presenting here is that the significant land cover changes around the like we saw on the classification maps, that the changes that were brought about by the fires of 2007 include like the degradation and the forest cover, and some classes taking over the area that was classified, like we saw the other vegetation class taking over the cropland. And also one other thing, I think we can say that the forest class was particularly like vulnerable to the fires of 2007. And then on the climatic parameters, the combination of high wind speeds and low precipitation rates create dry, fire-prone conditions. Then okay, I know I was very brief on the AUD and the AU and the angstrom exponent results, but I think it clearly shows that after the fire event, the AUD and angstrom levels were enhanced by the fire activity. Yeah, these are some of the references, and thank you.
Thank you so much, Ms. Mangala, for the insightful presentation. Do we have any questions for Ms. Mangala?
Thanks, Ms. Mangala, for your presentation. For interest's sake, I just wanted to compare your study with what is presently happening in the Western Cape. You know, we look at now the wildfires which are happening in the Western Cape, And when you compare with them, with this study that you have done based on the 2007 fires, what can you deduce and what has, in terms of your study, can be improved in terms of handling those fires in the Western Cape?
Okay, thank you. Not that I have looked at the fire activity in the Western Cape or investigations around that, but yes, similar study can be done like for any region, because that's what, like, I think that's what I actually mentioned on the problem statement, saying that we want to look at some specific regions of diverse land use. So like a similar study can be applied in investigating like those. Not sure if that is what you were asking.
Okay, what I wanted to check from you is that the current fires which are happening, is there any improvement in terms of analyzing the types of fires which are happening, because of they damaged a lot of areas? Yes, the case study in Mpumalanga, you find that it mostly because of there is those vast forests. So in terms of the impact that it has on the vegetation. So this is what I wanted to understand from just your study.
Oh, okay. No, not that I know of any improvements. I'm just not sure if like I understand what.
Sorry. Mrs. Lodge, may you please rephrase your question? Thank you.
She did a study based on the 2007 fires. Now, there are current fires happening in the Western Cape. I'm saying from what she has studied, researched, how can there be an improvement on handling the fires in the Western Cape?
Oh, okay, okay. Oh, okay. I'm not sure if I would advise like on anything I haven't looked at on my own study. But yeah, I just believe looking at those climatic parameters that may have influenced the occurrence of those fires, those contribute to the management of these fires, like knowing which climatic parameters or the weather and climate changes to look out for, and know like what you would expect.
Any more questions? There's another question, Prof. Kabea.
Okay, thank you for the presentation, ma'am. So what I understand from the study is just a monitoring strategy of the fire, but not handling the fire. Is it that's all right? You're not explaining the approach on how to handle the fire, but is how we can control or monitor the expansion of the fire. Am I right?
Oh yes, the monitoring, assessing of the fires.
Oh, okay.
That occurred. Yeah.
Okay, thank you.
Any questions? Thank you very much, Ms. Mangala. Our next speaker is Mr. Ibrahim Issa, who will be providing an online presentation. Is Mr. Issa online?
Yes, I am. Can you hear me?
Yes, we can. Thank you. Can you please share your presentation? Okay.
Oh, okay. Is it going to be from your computer or from my end?
We will stop sharing from our side. We have stopped sharing. You may share from your side.
Okay, I thought the presentation was going to be shared from your end. Let me put it on my laptop then. Just a minute, please. Apologies for the delay, please. I have to log on my laptop.
Mr. Issa?
Yes, sir.
Maybe let's move on to the next presenter whilst you set yourself up.
Okay.
Yes. That will
Thank
give
you for
time
that.
to relax and set yourself up. We'll introduce Mr. Mahaye, who's going to present for the development of an adaptive power-efficient electrical grid circuit for nanosatellites with integrated maximum power point tracking and lead prioritization. Mr. Mahaye.
Yeah, it's fine. Ladies and gentlemen, good afternoon. Apparently, when my mom was pregnant, my father dumped him. When he was asked, he said he just gave her some space. And then that's why I'm here today in the Space Symposium, presenting under the topic of the development of an adaptive power-efficient satellite grid system for power-efficient satellite grid system for the nanosatellites under the supervision of Professor Kapea and Mr. Msawenkosi Zon at the Durban University of Technology. And then I'm told I have just 2 minutes, so I'll do things quickly so that Dr. Loch can have a chance to ask questions. We got introduction, literature review, statement of problem, aim and objectives, methodology, and conclusion. So this has just been a proposed study. We have not yet got into the result. So for now, we don't have a result. We can take it as a proposed study. Now, the primary function of a satellite is to provide the navigations, the communications, and earth imaging. So from the olden days, we had big satellites that were taking a long time to build, and then more costs were required. Now, with the development of or the advancement of technology, we then came to the nanosatellite. So the nanosatellite is a small form of a satellite that ranges from 1 to 10 kilograms. That is easy to build. Also, it is having cost effective in terms of the costs. So the conventional designs had many drawbacks, such as the failure in electrical power systems because of the lacking of intelligent systems that were there. So the key trends now are integrating the intelligent methods to make sure that we can harvest and give the real-time data in terms of energy harvesting and load management controls. So we still have a challenge, though, in power management with the current systems. Now, here is the literature review. If you can see the diagram just provided now, we have this diagram is of April 2025. We have 1,100. What is this number? 1,192 that are operational. By the way, I'm from Kandla. Jacob Zuma is my neighbor. So we also have 244 that are operational. On the International Space Station, we've got 9 that are recorded there. And then on the spacecrafts that were launched from the spacecraft were 12. Now, fast forward to the red and gray bars. Those ones are the satellites that were noticed to have a launch failure, and some of them are having a deployment failure. Now, one of the reasons in the failure is the electrical power subsystem or the grid system. Not that it is the main cause, but it is one of the main reasons why these satellites are failing. So some researchers have dwelled much on trying to bridge the gap, as we can see that Ibrahim Ambaye has just tried to develop a similar with this one that I proposed on the CubeSat testbed Astro 1. However, there still was no dynamic power control. So in most of them that I've that I've checked or that I've visited, we still have that gap of integrating the intelligent load management together with the MPPT methods. Now, the statement of problem for this study is that as these nanosatellites are experiencing the failure rates, one of the contributing factors is the satellite grid system, as I just mentioned earlier on. So the nanosatellite is just having a very, very small space. Take for an example, if you talk about a 1 cube, it means it's having a 10 by 10 by 10 dimensions in terms of centimeters, 10 centimeters, 10 centimeters, 10 centimeter, as it is a cube. So you go up until you reach maybe a 12 cube. So that is a very, very, very constrained space in terms of having enough solar panels and the battery systems and all. So we just have a constraint in the space. So this causes a drawback in the efficiency of the electrical power system. As we know that in low Earth orbit, it takes about 90 to 120 minutes for a satellite to orbit around Earth. So in that specific time of 90 to 120 minutes, you have what you call an eclipse of about 30 minutes of that time. So that is quite a huge time for your satellite to not be under the extraction from the solar panels from the sun. So therefore, there is a need for an adaptive, power efficient grid system that can maximize energy harvesting and then dynamically prioritize the loads. So this research aims in designing the adaptive power efficient satellite grid system for nanosatellites only. I know one of the questions that might come will talk about the Starlink satellite and stuff. Those are not the nanosatellites, but I'll make an example of those. So this one focuses straight on the SGS of nanosatellites, incorporating the hybrid MPPT control alongside the intelligent load prioritization, so that we know when we are under an eclipse, some of the loads, more like a load shading, you know that these areas might not operate when you have this kind of, or when you have this, if you have this much of energy or power. So here as well for the load prioritization, we'll check which payloads or which subsystems critical, then we power those first. For example, if we have the camera, the computers, and the attitude, not altitude, attitude, okay. Then we can switch off some loads at a certain time. Then when it comes back to the exposure of sunlight, then we can again continue with the mission. So the objectives is to design the hybrid MPPT controller that integrates FLC and SMC. We're integrating FLC. The reason why we chose FLC is because the fuzzy logic control provides an intelligent control system, and then SMC provides a robust and more fast adaptability. Then we develop a load prioritization that categorizes and allocates power to subsystems. Then we will simulate the design. So here is the proposed diagram. We have the solar panels here. Outside the Earth orbit, or in the low Earth orbit, we have irradiance of 1360 watt per meter squared, as opposed to Earth, where we have 1000 watt per square meter. So we have these solar panels here. That's where the extraction of power will be. And then we have the PCU, the power conditioning unit, that is connected straight to the energy storage, where we will store our power. When we have enough power, then we will store some on the battery, so that when we have, or where we are short of power, then we will extract from a battery. So now here is our MPPT. And then this is the part that we are focusing the most, or this is the part that makes this study differ from the current studies. This part of integrating a load management algorithm together with the MPPT. So the load management algorithm, I know I have 1 minute, 30 seconds left. This load management algorithm just receives information or extracts information from the PCU, and then it tells which loads should be off at a certain time. That way we continue with enough power until we get back to where there is sun. So in conclusion, this research fills an international gap and supports smarter energy use. Proper design of this system will obviously prolong the lifetime of a nanosatellite. In conclusion, this study fills Sustainable Development Goal 7 about the clean energy, and Sustainable Development Goal 9 and 12. These are the references of the work that we've consulted. Thank you. How long?
It doesn't look like there are any questions.
It's fine. Okay. You mentioned that it's a study that is at the beginning.
Yes, doctor.
How big do you project the project to be in terms of your nanosatellite? The question came to me because of the amount of load that you are specifically talking about. Are you going to build a prototype of it, or you going to be limited into putting digital load to simulate? I mean the cameras and all others. And I'm looking forward to see how you will design the profile of these specific loads. Thanks.
A very nice question. Let's clap the hands for Dr. Logi, please. Due to financial constraints, it would be very hard for me to have a prototype at this time, but I will still obviously apply for funding there and there, because our faculty does not give us enough funds in terms of. But I will apply for funding and then I can build a prototype. But for now, it will only be limited in a simulation. Yes, and you can come visit me in my office if you want to see something.
We have another question.
Please give him a mic. I can see he's burning to ask.
Unfortunately, it's not a question.
Okay.
It's a response to your statement. I think I can extend a little bit of some money for you to prototype. So please come to my office. All right. Yeah. So you please come to my office next week.
Thank you very much. Thank you very much. God bless you, Dr. Farai. Thank you very much. Another funder, please.
Dr. Lochi, are you offering another fund?
I think I will follow him. He asked me to come into his office. So I will meet him when he goes to the office.
Thank you very much. We have a question. We have another question.
Thank you. For your PCU or like management, you spoke about that your project will be efficient and whatnot. So I'm interested in the parameters that you will be prioritizing to make it efficient, or maybe when you working on your simulation, what are the like prioritized parameters that will be considered?
Okay, another beautiful question, like you, Doctor, you are so beautiful. On the PCU, I will not exactly focus on designing the PCU. I will take what is there in terms of the latest developments, because the focus is much more on the load management. And then on the load management, the focus or the priority will be on the altitude, as well as the GPS of the satellites. Then the cameras and other payloads at that time will be off. So I'm not sure if I answered your question. It looks like you have.
No, for instance, in MPPT, you look at the current and the voltage, how it goes, and then when it gets to the maximum power that is being transferred, things like that. So with what you are doing now, what type of parameters that are more important or that you prioritize to make sure that you have the efficiency that you spoke about?
For the MPPT?
No, I mean, like you had the figure from your simulation, then you had 2 parts.
Yeah.
Yeah, so, you have the MPPT, you have all those devices which are on the left-hand side, and then you have, I think those are your, sorry, I can't see the loads.
Yeah.
So in terms of monitoring, what parameters that you will be looking at to make sure that, for instance, you said you prioritize the loads, the one that are more important than the other.
Okay.
So to do that, what is it that you look at like specifically to get that data that you are looking for?
On the loads or on the PCU?
Both, like when you, sorry, like.
Maybe I think that question would be nice as a recommendation if there is something you're recommending, or if you are not recommending, maybe if it can go through the email, then we can have enough time to look at the question, because now I'm trying to understand the question. I'm failing to understand the question. So that's why I'm asking if offline. What is offline? Yeah, offline.
Ask offline.
Oh, okay, please, Doctor. Oh, the office.
So there'll be 3 or 4 people going to the office. Dr. Farai, you can expect a lot more visitors. Thank you very much. People are very hungry. I have to apologize once again to Mr. Issa. Let's take 2 minutes to listen to Mr. Justin Witten from SANZA. He's going to give us a brief keynote address, a message from the CEO and from SANZA as an organization that is one of our collaborators and sponsors of the event. Mr. Justin Witten.
Thanks, Joe. Can you hear me? Here we are. Right. So firstly, apologies for the from detracting from the program a little bit. I was requested Joe to, by the organizers, forgive me, Joe, I'm blaming you for everything, to just give a little bit of insights from SANSA's side, because we were, working with the DSTI, DUT from the inception, ATNS, trying to get this program together for the past, obviously from the inception for the past couple of years now. And I've been involved, personally, professionally with the whole organization of the research center and everything. And I just wanted to share some thoughts, right? I'm not going to hold the guys up for too long. The lunch is smelling good and I'm pretty hungry myself. But I just wanted to touch on a few things. Firstly, to relay some thoughts that the CEO has repeated a couple of times in many forums. We had the National Space Conference recently, and what SANSA was pointing and showing is the direction that we're having, that we're embarking on, and which Mr. Matsapola this morning had alluded to in our 5 pillars of the new strategy 2025 to 2030. And space science has been an integral part of our daily business, right? There's not only, I think we've passed the phase of trying to convince the world, the government, the municipalities, the decision makers of the importance of the space weather and the impact it has on our environment. I think we've won that battle pretty well. What needs to come through clearly now is the innovations that come out of it. The groundwork is, it's never done. You always got to dig more gravel to put more road down, but the argument is placed. The ears are open. There's funding moving in the direction. There are customers, there are clients globally, ICAO, International Civil Aviation Authority, for example, that needs this information. It's a client of SANSA as a regional center, space weather center. So from that operational perspective, this data is necessary, it's required, it's integral for many operations, from military to electrical grids, as you all know, of the normal case studies for the importance of it. But more importantly, those things will never disappear. However, for you to now take the knowledge that is being created and consumed and created and consumed, and towards what Mr. Matsapola said this morning, to start trying to find not just the financial benefit or the from that kind of knowledge and that innovations that can occur, but to continually keeping the case to still be relevant, getting new applications for new customers which are solving problems. I think we've heard in many forums the VUCA world, the volatile, the uncertain, the complex, and the ambiguous world that we find ourselves in continually. And we're probably going to get another acronym next year because it's getting more complex and more, and technology is causing more complications as well, right? The more problems, I think personally, the more problems we solve with technology, we always have X+1 more problem to solve. And so, but the technology is a tool that we're trying to use, and we must use it appropriately to where it can be applied. All right. Like the old adage, if all you have is a hammer, you're only going to find nails to hit, right? Sometimes you don't need a hammer. All right. Technology can't just be used all the time for everything. My concern here that I want to share is that research for the sake of research is not, it's not productive. I think touching on the keynote address this morning, we were talking, it was mentioned that research is not easy. Doing something just because it's hard, it's like progress for the sake of progress is I saw this somewhere on someone's notice board. It's the philosophy of a cancer cell. Progress for the sake of progress is the philosophy of a cancer cell. We need to understand why are we doing, what is the purpose of it, and then that effort and that energy will naturally attract the necessary audience. All right. What I'm trying to focus on here is purpose. We have all this chaos, we have all these uncertainties, we have technology solving problems, we have climate change bringing distress and weather patterns changing, and we there's no silver bullet, right? So we need to apply our minds, and using space science and technology is one very effective tool because it's cross-cutting, as we know. It's cross-cutting. It affects everything from managerial sciences to psychology to agriculture to you just name it. It's fine. Financial systems, insurance, everything. All right. So what I want to do, my final thoughts on this is when in the keynote address, when it was mentioned that research is not easy. And I think we all know about this, that, the good discoveries, great discoveries always went through countless failures, right? How many attempts did it take for people to go across the ocean? We only hear about the successful one. We didn't hear about the 100 oaks that died and never came back, But it's building blocks. It's building blocks. And something I just wanted to just, sow into your minds, and that is, of course, you will encounter problems. You will encounter problem systems, problem tools, problem people, things that don't exist, that you need to put in place before you can even start getting to a point of seeing real progress. But what I want to just assure you of is going to hurt your ego. All right. It's going to impede progress, these failures, and it's going to frustrate you, your supervisors, your family, your loved ones, because the one amazing characteristic of, I think, if not everybody in the room, coming from a research and academic environment, the stuff we do is not easy. All right, it takes a certain kind of character and mind to want to do these things. All right, so it's a really special. It's a privilege to be doing things like this in the world that we live in, trying to serve our people and the benefits of increase the benefits of society through space. But also remember that the research is not about you, and there's a certain aspect that differs, makes you us quite a bit different from the entrepreneur, from the wealth creator. I'm not saying they can't coexist, but the research is not about you, okay? It is about getting you closer to a better question. And it's not a rabbit hole, it can become, but it's trying to get you to a better question. And your research and my research and the dean's work are all building blocks that eventually will somehow, when we're gone, when we're retired, when we'll all build to a better a better society, to bring benefits to our children's children, to the environment around us. And for me, that is the view that we cannot lose sight of. The humanity that we all want to enjoy and the freedoms that we need to protect can very easily be taken, can be nullified by numerical models. And so we need to understand what is the purpose. As we heard again, it starts with the human need, and it starts with the human and ends with the human. And let's not lose focus on that. And in that sense, again, you're not the only human, So it's not about an ego. It's about being able to benefit and contribute to society with the God-given gifts that we have. That's my thoughts on the work. It's been great work. I think it's fantastic research that's being done. DUT is doing a sterling job as a transformative university. You're not just transforming as what we envisage in government and strive for, but people's minds are being transformed, and I'm really happy to meet the students, listen to questions and the curiosity and the creativity that's coming out. I think there's a really amazing hub. This buzz that we have here is something that is fantastic, and I think the university and the DSTI just want to give them a pat on the back. The work is succeeding. I think there's a lot of fantastic new ideas, something very novel, and I think they've created quite a bit of a beautiful center of that, which is like a very good example for many other centers that we can start to open up around the country. Thank you. Joe, can we eat?
Thank you very much. Cheers, man. Thank you very much for the wise words there, Mr. Witten. Ladies and gentlemen, we will be continuing after lunch. May I request that we have a 30-minute lunch as opposed to the 45-minute lunch that we had prepared before. Lunch will be served next door as we step out. Also, when you finish lunch, you may browse through some of our exhibitions, and we also have exhibitors outside by the lunch area. So please take that time as an opportunity to also go through that. May you enjoy your lunch. Thank you.
Hello, I can hear you.
Mr. Isa, I think we are going to ask you to project.
Okay.
Okay. Let me see. Who's paused?
Just a minute, please.
Thank you. Mr. Isa, in the interest of time, Dr. Logi will no longer be asking questions. So you will only ask half questions, not full questions. We will request that you try and expedite your presentation. If you can limit it to 8 minutes so that we have 2 minutes of question time. That's why I said Dr. Logi will only ask half questions. You may go ahead and present. Thank you.
Go ahead, Mr. East.
Okay. Thank you very much. My name is Isa Ibrahim from Durban University of Technology. I'm here to do a presentation on AI-based cognitive radio for space weather resilience, a geomagnetic data-driven approach. So this is the outline for the presentation. We're going to walk through from the introduction up to the reference where we're going to finish the presentation. So for the introduction and the background, we're looking at satellites and CNS systems, CNS for communication, navigation, and surveillance. These systems are mainly used for navigation and remote sensing, and they operate through the ionosphere. So the issue here is the ionosphere is prone to disturbances, which normally happen from space, can be as a result of solar flares, and then you get like geomagnetic storms that affect that layer. So with that, we get an issue with communication via that layer, which brings the need to have like a resilient strategy to ensure that communication carries on even when we have a bad weather in space. So for the motivation, in 2017, there was a solar storm that actually caused a blackout. And earlier on, a speaker from ATNS also complained about bad weather and it affecting systems. So for this, you can imagine having an important flight or maybe a patient that is supposed to go from one point to another, and then that flight being rerouted because of this storm affecting the communication condition. So we need to do something to ensure that things like this do not happen. We need like a proactive approach, not a reactive approach, which mostly happens now. It's more like reactive. You detect there's a problem and then you reroute a particular system that is making use of that communication line. But for now, we want to ensure that we have a proactive approach. We sense what's happening, we find a way to manage it and then go through the situation as it. So that takes us to the concept that we have here to apply AI based on historical data. For the test that we have done, we use historical data to be able to see if it's going to give us what we want. So with that, you're able to predict with KP values and know how to go about communicating via channels on the system. With this, for the literature review, we have foundations on cognitive video, whereby we see different ways of dynamic spectrum allocation. But this has issue because there are no external disruptions in the system, such that they don't come from external environments. And then we have AI-based approaches that are used in some literatures. However, this only focuses more on interference and traffic metrics. It doesn't also factor in the environmental effects that we have there. And when you look at space weather impact on communication, they look at the geomagnetic storm approach, and then it's known to cause issues to high frequency radios. But then research on this is existing, but there's no integration to show that we can use intelligent systems to mitigate this issue. So that's what we're trying to do in this. We're trying to bring in cognitive video and AI to find a way to mitigate this problem. So for the conventional cognitive video systems, they don't factor external environmental factors. They're just more focused on the primary users and resources in the systems that have been allocated. But then communication fails due to just environmental issues like the geomagnetic storm that I'm talking about here. So we need a proactive strategy. And this is why we're looking at this. How can CR systems remain reliable during space weather events? So for this, we aim to develop an AI-based cognitive video framework that adapts communication strategy using geomagnetic KP index to improve CNS reliability during space weather disturbances. So what we're going to do is we're going to analyze the weather variability that we pulled up online based on the space index from NOAA. And then we have a model for the weather impact on spectrum performance. And then we design a KP-aware decision strategy for cognitive video. Then we do a comparison between the baseline and the AI approach that we have taken to see the improvement that we could get from this particular approach. As for the methodology, we use the dataset from September to October of 2025, fetched from the NOAA website. The key parameter is a planetary KP index, which is like a geographically known standard for index when you talk about weather conditions in space. And then we did a classification for the weather conditions. When the KP is less than 3, it's an active state. When KP is between 4 to 5, it's when KP is less than 3, is in a quiet state. When the KP is greater than 3, that's between 4 to 5, we have it in an active state. And when it's greater than 6, that's when you go into the storm state. Then finally, for the system model, we're looking at a hybrid satellite terrestrial cognitive radio system, which has a state vector. It's defined there for the state, whereby for each state that is going to be fed into the machine learning model, it's going to like take note of the channel quality, the interference, the demand, and the geomagnetic activity, whereby the KP as the geomagnetic activity is the main thing here that brings about change in this particular method that we're going about. So like I mentioned earlier, this is rule-based because it's going to work based on a fixed system. Somewhere in the work, we try to bring in a part whereby you can have a look and understand what reinforcement learning can bring about when you bring in this. And then the evaluation metrics are here. We try to focus on reliability. That's the link success probability, the outage probability, the likelihood of failure. And then we have the mean time recovery, MTTR, which is the time to restore the service. So on that, we're able to, in figure 1, you can see the daily index variation for KP, whereby we have the green line as the threshold for the quiet weather. So from the green line to the yellow line, that's where you have the active storm threshold. And then from the yellow line to the red line, that's where you have the storm threshold. The storm threshold actually isn't much and it doesn't happen much. But then as something that might occur, we should have a plan for it because we don't know when it's going to be necessary to make use of this solution. So on the right side also is figure 2, which has the distribution of the KP values, still showing the active period, the quiet, and then the storm periods. We can also see here that the active is much, the quiet is much and the active isn't that much, whereby the storm is just a little on the end. So for our results, here we have the baseline versus AI CR reliability across the study period. So you can see here that for the baseline, it always falls whenever you have a very active and approaching strong weather condition. But looking at the AI model, it tries to hold up the communication. The reliability is there, but it doesn't fall to the level whereby you have the baseline model falling. And then on the right-hand side, you also see there that you see the improvement with the AI CR model, which is the one in orange, and then the baseline is in blue. And then when you use conceptual thoughts that we had, maybe you try to look at it from the perspective of reinforced learning, it can further boost the model from our own perspective based on what we try to see, such that it works in a reinforced manner. It keeps on learning based on the previous output. So it's more like a control loop, like a feedback control loop that keeps the system moving on and on, as opposed to having fixed set of values that you have the range that you need to go with for the prediction in the system. So with that, we come to the conclusion whereby we've established that space weather affects communication more than often considered. And this study tries to bring in a KP-aware cognitive radio system in order to improve the resilience of CNS by anticipating disruptions based on historical data. That's for the test to establish this. But for the actual work, if it's feasible, we see it being done in real time. If that's been sent as feedback, the cognitive radio system should be able to adapt and then know what to do in an event of a disaster in space. And then finally, this bridges the space science and air wireless engineering field. So here we have our references. And then finally, we extend our sincere gratitude to DUT DSTI Space and CNS Research Center for their invaluable support in the work that we've been doing. That's all for now. Thank you.
Thank you, Mr. Issa. Do we have any questions for Mr. Issa? Dr. Logi is not in. In the absence of questions, we'll proceed to our next presenter, which is Mr. Silva from UKZN ASRI. Thank you.
Hello, hello. All right. I've only been told I have 8 minutes and counting. 7 minutes now. So I will fly through this presentation to try and make sure that there's more time for questions. So I am an engineer at the Aerospace Systems Research Institute based at the University of KwaZulu-Natal. And today I will be taking you through my IAC presentation from that I presented in Sydney, Australia earlier this year, which focused on our current testing and performance analysis of our 22 Newton green propellant thruster that we are developing in-house. I'll briefly go through what the project is that we're currently developing, our lab thruster that we are using for our testing, the test facilities used, basically what one of our tests that are busy focusing on, which is focused on the catalyst bed configuration, what results we've acquired so far, and the future work and conclusion. So unlike your traditional liquid rocket engines, monopropellants contain the fuel and the oxidizer in a single mixture. So there's lately been a large push to greener propellants to replace existing monopropellants such as hydrazine, which are extremely toxic and expensive. So there are additional monopropellants out there, but high-performing monopropellants which can replace hydrazine consist of 2 ionic fluids, namely ADN and HON, which is ammonium dinitramide and hydroxyammonium nitrate. So our main focus is on the second option, hydroxyammonium nitrate, which we actually fabricate in-house in our propellants lab. So you normally mix it from nitric acid, which is then dripped into a set amount of hydroxyamine. The propellant that we're busy utilizing for our test is actually a mixture of methanol and additional constituents. And to get this final propellant, which is SHP-163, which is developed by JAXA in Japan, we have to increase the concentration of the HON to approximately 80 to 90%. After that, we then add the constituents inside of our reactor And then depending on what the final pH is and also our measurements, we finally get our overall and final propellant SHP 163, which has been verified numerous times by FTIR using existing research papers and of course our propellants. So the thruster that we utilize is known as the battleship thruster. This thing is bulletproof. So it consists of 8 major components. So namely, it's a copper nozzle at the base, which has an expansion ratio to atmosphere. Thereafter, you have a copper heating jacket, which is also an instrumentation ring that consists of 6 30-watt heaters. It also has 3 thermocouples to measure the temperature of the jacket, 2 thermocouples to measure the temperature of the catalyst bed, and also a port for a pressure transducer. Furthermore, there are also internal catalyst beds which contain granules which are used to decompose the propellant. And then the final component of slides on top is our injector assembly, which is a shower head injector. So the catalyst bed configurations, there are 5 of them in total. So the idea behind here is to try and identify what the optimum length and configuration is. So we're busy identifying basically how much fine catalyst bed, which is placed on top, and coarse catalyst, which is slightly larger in diameters at the base. So the whole idea of splitting, utilizing 2 different catalysts is to try and allow for a smoother startup with less pressure fluctuations, but also we need enough fine catalyst to make sure, enough coarse catalyst to make sure that we don't have a high pressure drop so that we can maximize performance and efficiency. For our current test, we utilize a platinum coated alumina catalyst. The coarse catalyst was 14 to 18 mesh, and the fine catalyst was 20 to 25. The test facility was, it is placed inside of our CAN facility on the UKZN campus in the mechanical engineering building. While this test rig is capable of testing liquid rocket engines up to 2 kilonewtons, there is a designated panel for the SHP testing, which utilizes a helium blowdown system. The LabVIEW and NR system is used to control all of the valve actuations and also to acquire all of the data from our temperature, pressure, and load cell sensors. The first test conducted utilized a 15 millimeter fine quartz catalyst bed and a 31 millimeter quartz catalyst bed. The system ran for 500 milliseconds on and 2000 milliseconds off for a total of 5 pulses. So the first results required were actually really positive. So we were able to achieve a maximum thrust of 21.22 newtons, which was inside of our 5% theoretical thrust of 22 newtons. However, from the graph, you'll see that the first 2 pulses are slightly below. So this is partly due to the underperformance of the catalyst. Number one, platinum not being the ideal material to decompose SHP 163. And furthermore, because of that lower decomposition temperature, or because of the insufficient temperature, should I say, the catalyst wasn't actually able to produce max performance. However, from pulse 3 onwards, you'll see how consistent the thrust was. This was because we finally achieved that optimum temperature of 500 degrees and higher inside the catalyst bed to sufficiently decompose the propellant. We used the final 3 pulses due to their consistency to calculate the response characteristics, which were really, really good. So we found that the response time, ignition time were within the 22 Newton class range. However, the rise time, which is the time taken for the thrust from 10 to 90%, was slightly outside of the 200 millisecond range that we were already hoping for, but was still within 10% target, which was encouraging. The decay time, however, was also insufficient, as we did want this to also be below 300 milliseconds. And on top of that, from the graph, you can see that the thrust doesn't actually reach 0 due to the insufficient decomposition with the catalyst. You can also see from the figure on the right-hand side that we blew a hole. You would have seen some sparks coming out in that video. So due to the high temperature of the decomposition gases, it ended up melting a hole in the base ring, leading to our coarse catalyst being ejected. For the second iteration, we added a graphite ring to try and assist with the retention of the coarse catalyst. And we also reduced the time from 500 milliseconds to 200 milliseconds, keeping the 2000 second in between the pulses. So again, we had encouraging results. We were able to achieve a peak thrust of 22.72 newtons. However, there were the first 3 pulses underperformed. This was partly due again to the reduced catalyst bed temperature before initiating our testing. From the results, we can see though that there was also a dramatic decrease in thrust after the 4th pulse. This was due to the catalyst bed busy failing. Unfortunately, the stainless steel ring and the graphite ring were not able to withstand the pressure and the temperature that we were busy operating at. However, the results are still encouraging, consisting of consistent chamber pressure. And looking at the response characteristics, which we calculated using the first 4 pulses, we're able to see that they were very close to the first test that was conducted. One of the reasons why we also had that drop in performance for the first 3 pulses was due to catalyst poisoning. So as you can see, the dark contrast that we have between the 2 catalysts, that indicates that the graphite ended up coating the platinum, reducing the performance of it. Furthermore, you can also see that there's a large volume loss. This was due to shrinkage of the alumina due to the high decomposition temperature. So in future work, we are throwing stainless steel out the window. We have replaced it with a tantalum disc, which should be more than sufficient to withstand the high decomposition temperature. We're also going to be utilizing iridium-coated alumina, which should have a much significantly better method of busy decomposing the propellants, allowing for more consistent and efficient thrust. A huge shout out and thank you to all of our sponsors, namely NRF and DSTI for their continued support, and then also to SANSA, UKZN and Swagelock for their assistance within this project too. Thank you.
Thank you, Mr. Silva. Do we have any questions for Mr. Silva? Dr. Logi is back. We have a question there at the back, Dr. Mazibuko.
Thank you so much for this presentation and the knowledge you've accumulated in this institute. Please tell us if the DUT Space and CNS Center were to go to the International Astronautical Conference in Turkey next year with an intention to attract investors, foreign direct investors to invest in these concepts and initiatives that were presented today. And JAXA, SpaceX, or whoever says no, DUT, I cannot assist you or I cannot partner with you because you are having students that can leave you at any time they see new opportunities or green pastures, or maybe when they complete their degrees, they will leave you. What advice you can give us in that regard? Thanks.
So you're busy asking more about retaining people, correct? So in all fairness, so number one, there's a lot less red tape here in South Africa. So the amount of support that we have from governments and from the university, you won't be able to do a project like this anywhere else in the world and accelerate it like we do and have the support. So for instance, if I had to compare us to the recent ISC in Australia, they, funny enough, can't actually make this propellant without having a list like this of forms and approval from government, which just further delays it. Whereas all we have to do is just get approval from the police and get clearance, and then also, of course, have approval from the university. And from that, because we are a university, we are allowed to heavily invest and research these propellants. On top of that, also, I can just speak on behalf of ASRI. So the amount of experience that you get hands-on in ASRI is also a lot more that you'll get anywhere else. So for instance, this project is only manned at the moment by 3 to 4 employees, whereas in somewhere overseas, for instance, you'll be one of maybe 100. You'll be in charge of maybe designing 6 bolts out of the entire thruster or just the heating system. So the amount of opportunities that you have here in South Africa are significantly outweigh anywhere in the world. And I think it's these sorts of matters that that must excite our engineers and our scientists to stay in South Africa and contribute and make us one of those leaders, not only in aerospace, but in all systems like that.
Thank you, Mr. Silva. Do we have any other questions? You can run. Yes, thank you. Thank you, Mr. Silva. Our next presenter is Mr. Hlongwane, and I would ask that Mr. Ador get his presentation ready as Mr. Hlongwane is coming on stage. Thank you.
Greetings to everyone. I hope you are all well. My name is Michael Hlongwane, and I'll be giving you a presentation on thermoelectric materials. So this is part of my ongoing PhD project, which I started 5 months ago. So there isn't much that I'll be presenting. So all that I'll be doing is giving you an idea of what my study will be all about. So I hope you'll enjoy this presentation. So the title of my study is Thermoelectric Properties of Bismuth Antimony Thin Films Deposited through Pulse Laser Deposition. And this is a project supervised by Prof. MK Model, who is currently based at the University of KwaZulu-Natal. Okay, so I'll begin with the outline of this presentation. So we are going to look at our introduction, which will tell us more about what these thermoelectric materials that I'm creating are. Then we'll look at the literature review, which is just a continuation of that. Then the statement of the problem, but not in the traditional sense. So it's, and also the aims and objectives, methodology, expected results, and then we'll conclude with our references. Okay, so thermoelectric materials are the kind of materials that help us convert heat into electricity. If you remember Mr. Capital, he talked about the job of a physicist being to have those ways of converting energy from one form to another, like understanding those methods since energy cannot be destroyed or created. So he spoke about something like that. So here we see a typical configuration of thermoelectric materials, which means most thermoelectric materials out there take on this form. And we see some equations as well that help us quantify some of the parameters that we use to assess the performance of these materials. So you can use thermoelectric materials in 2 modes. One mode is for power generation, which we will call mode number 1 from that next to that equation number 1. Yes. So the other mode is the refrigeration mode. And the refrigeration mode, it's governed by the Peltier effect, whereas the power generation mode is governed by the Seebeck effect. Then we have the Thomson-Kelvin relation, which sort of like gives you the relationship between those two, Seebeck and Peltier effect. Okay. Now, to understand the importance of our study, you'll have to look at the applications of these materials. And their application ranges from sensor application to waste heat recovery. And we also have used them in the past as far as space science is concerned. We've used them in the Cassini satellite to power the instruments on board. And on figure 4, we can also see how a typical thermoelectric module looks like. And this module can function as a power generator when you use it via the Peltier effect. And you can also use it for coolant. Sorry, I think I confused the two. So when you're using it to cool, we say you're using it via the Peltier effect. Then for power generation, we say you're using it via the Seebeck. Yeah, correct. Okay, so this is just some schematic that tells you what physics goes behind your voltage generation from the temperature gradient. So remember, you apply heat and then you get voltage. So yeah, I won't explain much on that, but if you have some questions, we can tackle that one. So we also have to measure those parameters that I talked about, of course, once we've created our materials. So this is how we are going to measure the Seebeck effect, which will help us calculate the thermal power. So when we talk about the thermal power, we are talking about some parameter that relates how much energy output you can get at a given time from your thermoelectric material. So this is how the configuration is. Then with that Seebeck coefficient that we measured on the previous slide, we would like to also measure the thermoelectric figure of merit, which we call ZT. And what this parameter does is it helps us see if our material is commercially viable. By that I mean it helps us see how efficient it will be when you put it into use. So you are expecting ZT of 1 or more or higher to say that your material will be a good thermoelectric. So we are going to measure all those coefficients, and what I want you to help me with is help me find, I mean, if you know a place where they can help me with the thermal conductivity measurements, because currently we've developed some instrument to measure the Seebeck coefficient, and we already have the 4-point probe technique to measure the electrical conductivity. But what we don't have is the laser flash analysis. If any of you there knows where we can get that, I'd appreciate your help. Okay, so this is my chosen material, bismuth antimony. And these are some of the things we know about it. We know that it is a classical low temperature thermoelectric, and we know that it operates very good at room temperature and below. And it's also a topological insulator, meaning that it is insulating in its bulk or bulk interior and conducting on its exterior. And that makes it more interesting for electronic applications. And we've chosen this material for our study because few studies exist that covers this, especially in thin film forms. Okay, so these are some of our objectives. Due to time constraints, I can't talk more about it, but I can summarize it for you. We just want to create these materials and then optimize their performance. Now, this is how we are going to prepare or create our bulk versions of these materials. So the idea is we want to create thin films from the bulk form of these materials. So the bulk version of them will be created following this process outlined in this slide. So we'll mix the powders, then grind them, anneal them, meaning heating, and then hot press them into the dense pellets, then perform a pulse laser deposition using this machine. It's quite an expensive machine. So yeah, this machine will allow us to control some of the parameters that will decide or that will determine the quality of our thin films. So here we'll control the background gas type and then the pressure, also the substrate temperatures, and all those other important parameters. So yeah, we'll also characterize our materials using these techniques: XRD for crystallinity, SEM or TEM for surface morphology, and then EDS for elemental composition, like want to confirm if our thin film has the same elemental composition as our bulk version of our bismuth antimony. Then we've also created our custom Seebeck rig that will help us measure the Seebeck coefficient. We are done. We got it working at the moment, but we are just trying to now order the formal PCBs so that it doesn't look messy like that. It looks so fine and good, because you can't fit wires into that space. So we need to miniaturize the circuit connections. And then this is what we expect. So we are expecting that if we compare the thermoelectric properties of our thin films and the bulk material, we expect that the thin films will show an improvement of this thermoelectric figure of merit ZT. And the reason being, it's because of the grain boundary introduction that our thin films will sort of have. So if you want to know more about that, I can explain it for you. But the simplest way of putting this would be to say your thin films, let's say maybe it was polycrystalline, confirmed by XRD, of course, and also TEM. If you see that it's polycrystalline, then you can imagine the atomic planes within each of those minute crystals being distorted by this pulse laser deposition thingy, you know. So by distorting those atomic planes, you are lowering your thermal conductivity, which is a very, very big problem that we face in material science, especially as far as thermoelectrics are concerned. So thank you very much. I would like to acknowledge my laser material research group and also NRF for funding this research work. So
Stop, please don't go away for questions. Oh. Thank you, Mr. Flongwane. I am now going to welcome questions from Mr. Flongwane.
Am I visible?
Thank you. You have 8 minutes or less.
All right. Thank you so much for the opportunity. Greetings, everyone, and greetings to the director of the Space Science, Prof. Ojo, and my supervisor, Prof. Kabia, and another wonderful personality, Dr. Loji. I'm presenting on the quantum enhanced ultra-low frequency signal analysis for preventive airborne navigation safety. So fundamentally, there are some number of increasing cases of unexplained aircraft navigation failures and losses. Now, these failures and losses has come about as a result of inability to detect certain major symptoms that show up before any major failure or losses occur. These failures and losses normally are embedded in some small signals within the ultra-low frequency range or band. That has become very difficult for normal conventional spectral methods to detect. So typical example like the wavelength transform or normal Fourier transform. Because their inability to detect these faults, there is kind of always what we call this is not a proactive measures that takes place to detect some of this problem. Always when the problem happens, before some of this system will be able to detect. So what we are trying to do here is to come up with a system that can detect ahead of time to know what kind of situation our system is bound to find. But most of the time, these symptoms that show up are embedded in the losses itself. So it is very, very difficult for normal classical computational system to detect some of these things. So we decided to come up with a system where the actual precursors indicators that show up in the losses itself can actually be detected. So there have been a number of literatures that have gone on. So a method like a ULF magnetometer analysis have been applied. And the major concern here is that it has high false alarm rate in the noise. So remember, all these signals are mainly within the noise. That doesn't give actual fault indicators or symptoms that give us an idea as what is yet to come. And also, another method was also adapted using the FFT and the wavelength spectral decomposition. The major problem here was that our limitation here was that it is ineffective for low amplitude signals. So again, when it comes to low amplitude signal, it was able to detect it very well. Another methodology that was adopted using the AI, specifically the LSTM and the CNN. Here, the problem was that it has a limited post-event analysis. So that is also another issue here. Then another method also was adopted where they used the quantum neural filtering. The problem here is that no aviation data validation was used here so they use the synthetic data to do actual simulation. So what we are seeking to do here is to adopt the quantum AI ultra low frequency fusion. So this is where we intend to use airborne navigation safety data to come out with a detection where we'll be able to detect the actual fault based on the symptoms that our system will detect to tell you what kind of fault that is here to come. So basically, we want to look at those ultra low frequency signals that gives us an information as to what's here to come. We want to be able to fish them out as early as possible so that any harm that's supposed to be done will be prevented ahead of time. So the main objective here is to develop a quantum enhanced ultra low frequency signal analysis framework. So we are not actually building a device, but we are building a computational framework associated with the geomatic and the mechanical stress variation. Geomagnetic, and the mechanical stress are very important because when it comes to geomagnetic, we are looking at some interference that exists between the speed of the sun and the earth. So between that, there's a lot of interference that goes in there. And these small, ultra low frequencies carry those informations that actually affect our navigation system or aircraft communication system. And the aspect of the mechanical stress variation, we are looking at the structure of the aircraft itself and also some component that appear to be old that also causes some of these ULF signals that generate this ULF signal to give us some indications as to what is going on. And like I said earlier, these signals are very small that they are not easily detected by the conventional classical computational analysis. Then we'll design a hybrid quantum AI algorithm integrating a quantum in sparse signal decomposition within a neural pattern recognition. Then we'll see how we evaluate this to see how the accuracy and also false alarm reduction compared to the conventional one also will be like. Then lastly, we want to demonstrate the real-time feasibility of the proposed framework for preventive monitoring, both man and unmanned aerial platform. So this is a system model. So the input is such a way that we have a geometric disturbances within the range of 0.01 to 30 Hertz, very small. Then we have the mechanical stress also in avionics drift, then some atmospheric or sensor noises. So from that stage, we'll be able to, we gather all this data and we gather them by way of using other sensors like antennas and other things. Then from there, we pre-process the data. So in this stage, the pre-processing, we adopt a system known as the bandpass filter and also the noise and the normalization approach to process the data that will be captured. Then from there, while the data is processed, then we can go ahead to encode them in a quantum form state. So in this case, we are adopting two major, very important. This is where the actual work will be done. We adopt them using what we call quantum Fourier transforms and entanglement. Then from there, the prediction will carry out with the help of the AI. So methodologically, this is how the system works on. So multi-source flight telemetry and the magnetometer data will be sampled within the ULF range. Then based on this, this is how the system is modeled, where the ST represents the signal, the raw electromagnetic signal itself, adding the noise aspect of it, which is the N of T. So with this one, everything is embedded in the major noises, where these noises are in a very small form to detect. Then once we adopt the bandpass filters to isolate the low frequency, we use this approach to do that. Then from there, we apply the quantum inspired feature decomposition approach, where the signal that is captured and processed will then be encoded in the quantum.
Mr. Adjo, can you hear me?
Can you hear me?
Yes, can you please try and wrap up? Thank you.
Okay, thank you. So then from there, we apply the AI, then evaluation is carried out. So the evaluation now work would then be compared with that of the normal FTC and wavelength and the CNN methods in terms of the signal detection sensitivity and that of the false alarm rate. So these are the results that we get. We can see that when quantum enhanced it is more better compared to that of a classical. And this is also in terms of the sensitivity with respect to the noise signal ratio, that one to be able to detect the corresponding noise, especially the negative side, which is very weak. We can see how the quantum side is behaving with it. In conclusion, this research is still ongoing, and we intend to have it published in a very near future. So thank you so much for the opportunity. I'm very grateful. Hello? Hello, ma'am. Can you hear me?
Yes, there's a lot of clapping going on, and I'm inviting questions for you.
Okay.
There is one question. Doctor?
Okay. Thank you. In your presentation, you spoke about, I think that was the main thing, the low frequency. If I make a mistake, please correct me. I believe that low frequency comes with low speed and then low noise. So if you are trying to detect the bad signal as fast as possible, why is it that you are using the low frequency? I understand in terms of noise that there's low noise, but how do you combine it with machine learning and all those things to make it to be fast to detect? I didn't really understand, but I think you tried to explain, but can you please explain more on that?
Okay, thank you so much for the question. So when it comes to ultra low frequency, as you said, is a very low frequency signals that are very, let's say it's very difficult to modulate this kind of signals. So because they are low frequency nature, they are always embedded in a very much more noise environment. Let me put it in a very typical example. Normal voice, if you use the natural voice, and somebody is standing away from a distance of 10 meters, if we speak normal voice, the person will not hear. Why? Because it has been interfered with noise. It has been interfered with noise. Unless you increase your voice, no matter how you increase, the person can't really hear very well. Unless you are someone who has very tough voice, then the person can hear a little. So that's how a low frequency always have a problem, because they are always dominated with noise. And a normal classical computational signals can't detect this noise. So when it comes to aircraft system, because we are in an environment where these noise are so rampant of a major. So you remember one of the previous presentation make from his explanation, this is one of the major problems they are facing. So you need a system that can detect this at a very fast pace and also very clearly to tell you what kind of signal at any point in time you're experiencing. So you have aircrafts where these things are very difficult to detect. By the time you realize whatever has happened has happened. And that is basically what we are trying to solve here. I don't know whether I've been able to address it.
Yeah, maybe. So what is the issue with the high frequency? Because I believe it has less noise distraction.
Yeah, it's not about frequency itself, it's about the interference. Because the concept of frequency will be able to get to you depending on the number of noises phases. So like I use normal voice. Somebody away from 10 meters or 100 meters can't really hear you because of the interference and the noises. But if you take it in the day or night time where there's no noises, you speak, the person can hear you very well. So it's not the frequency itself having a noise, but it is ability for that a situation whereby that frequency easily get affected by noise. That is and we are saying that for the ultra low frequency band, they are much more influenced by noise easily.
Thank you, sir.
Thank you very much, Mr. Ado. Now I'm going to ask, excuse me, Miss Namsa, I resigned here. Why am I standing here? May I request the Prof. Ratilal and some of our guests. Okay, Prof. Ojo, you are going to get the honor to present the gifts to some of our guests who are catching a flight pretty soon. May we have the lights on, please? In the meantime, Mrs. Trilly, please get to the podium so that you can give us your... When I was a presenter, I used to be told to flap. You're going to be our last presenter. The last presenter must always flap. That is to finish like a pro. Let's hope we are going to flap. Lily is our last speaker. Mrs. Lily, the stage is yours.
Good afternoon, colleagues. I am Nompumelelo Qili, presenting Space-Based Wireless Power Transmission, a Future for Global Energy Supply. Disclaimer, this is, I'm presenting the area where I'll be doing a doctoral study. So the aims and objectives are summarized. Since I'm still gonna be submitting my PG2, I'm not gonna go all out. I'll just summarize. And okay. This is the outline of what I'll be talking about, which going to be the introduction, literature review, problem statement, aims and objectives, methodology, and to reference. So the world's energy, sorry about that. The world's energy demand continues to rise rapidly due to population growth, industrialization, and technological expansion. While renewable energy sources like solar and wind have made great progress, they still face significant limitation. They depend heavily on weather conditions, daytime availability, and require large area of land. To overcome these challenges, researchers are exploring wireless power transmission a technology that allows energy to be transferred through space without the use of any power lines. This concept opened up an exciting new possibilities, especially when extended beyond Earth. Extending wireless power transmission into space enables continuous solar energy capture and global distribution. Therefore, space-based wireless power transmission takes advantage of the constant and abundant solar energy available in space, offering a revolutionary solution to the world's growing energy demand. The concepts involve capturing solar energy using space-based collectors, converting it into electromagnetic waves, wirelessly transmitting it to the Earth. The ground-based rectifying antenna, also referred to as rectainers, then convert the received energy into usable electrical power. The key concept of the space-based wireless power transmission include the space solar collectors, wireless transmission, and earth-based rectainers, all working together to enable efficient, continuous, and sustainable energy delivery. This research supports the broader vision of creating a clean, reliable, and sustainable global energy solution powering directly from space in alignment with United States SDG 7. So the progress toward SDG 7 has a positive ripple affecting on several other SDGs. Therefore, why space? Why space is such an attractive option for future energy systems? Firstly, space offers constant sunlight, meaning there are no clouds, no weather, no nighttime interruption. And this means we can capture solar energy 24 hours a day with maximum efficiency. There is also no atmospheric interruption, so the sunlight is stronger, more consistent, and available all the time. This means we can generate a constant and stable flow of energy, something terrestrial renewables struggle to achieve. Secondly, operating in space eliminates the effect of absorption and scattering that reduces efficiency in ground-based solar collectors. This allows for more efficient energy capture and conversion, making space-based solar power not only clean, but also highly scalable. Another important motivation comes from the ongoing work from NASA, JAXA, and the European Space Agency, who are already testing solar power satellites capable of wirelessly transmitting energy to Earth. Their progress provides a strong fundamental and inspiration for future exploration in this area. Finally, space-based energy systems have the potential to complement terrestrial renewable sources and enhance global energy security by integrating power collected in space with existing renewable grid on Earth. We could create a more reliable, sustainable, and balanced energy network captured of capable of meeting rising global demand without harming the environment. Literature review. Here are 5 journals that align closely with my research area. We are currently working on a systematic review article in which the existing literature will be thoroughly analyzed to identify research trends, technological advantages, and existing gaps within the field of space-based wireless power transmission. So coming to problem statement. The main challenge in space-based wireless power transmission centered in efficiently converting and delivering energy from space to Earth. From this system, to operate efficiently, 2 key components must perform fluently, which is rectennas and beam steering mechanism. So with this research, I aim to design and optimize a rectenna that can capture high frequency microwave energy and convert it into usable electrical power with high efficiency. At the same time, we will investigate beam steering techniques that allow precise control of the transmitted energy beam, ensuring it remains accurate, aligned with the receiving station on Earth despite movement and distance. Space-based collectors, maths, that one I'll focus on it when I'll be doing my postgrad. Yeah, that is where we'll need funding to send these maths to the space. So some of the objectives of my study will be to model and simulate rectenna design to maximize microwave to DC power conversion. The second one is to create and validate control algorithm for accurate beam steering from space-based satellites to Earth-based receiving satellites. Emphasis will be placed on achieving high precision and adaptability in varying atmospheric conditions. The other one is to combine then the optimized rectenna and the designed beam steering to algorithm in simulation environment where I'll use MATLAB. I'm still learning how to use ANSYS, and I'll also be using Python. Then I'll combine these just to evaluate the overall system performance and efficiency. Then I'm aiming to build a small scale project for experimental purpose just to validate the simulated results. How am I going to do that? Firstly, my study is going to follow the positivism design, and I'll adapt the quantitative experimental research design, and then I'll employ Okay, thanks. So to achieve these objectives that I've mentioned before, this research will follow the simulation-based and design-focused approach. Firstly, I'll analyze the difference in rectangular configurations, that is shape, material, diode types. And then secondly, explore beam steering techniques such as phase array control and dynamic beam shapes to understand how the transmitted microwave beam can be directed and stabilized for accurate energy delivery. And then finally, the results from the rectangular design and beam steering simulation are evaluated together to assess the overall system efficiency and feasibility of a space-based wireless power transmission. And the expected results will be to optimize space-based wireless power transmission efficiency model, design framework for future space power satellites, and quantifying performance material such as power, density losses, and beam control. Then lastly, technical insights into practice, deployment, and grid integration. These are some of the references that I used in the paper that I'm writing. Thank you. I'm going to allow suggestions since it's the area that I am working on.
She's disinviting questions. We are inviting questions.
Yes.
AP roving microphone.
Lamin.
You can hear me? Okay. Thank you for your presentation. I just wanted to find out quickly, why are you going to use both the MATLAB and Python? Are you expecting to get different results, or what is the reason behind it? Thank you.
It's because I can use both. I can write scripts on Python, and I can also work with MATLAB. So, but what I noticed is NCs need a background on Python. So for me to be able to use NCs, I must make sure that I know Python. So I'm just fusing all together and then decide which results I'm coming up with, and then the one that will be suitable and best for me, then I'll go with them.
Any more questions for Mrs. Tilly? Soon we'll be calling you Dr. Tilly. Thank you very much.
Questions?
Yeah.
Question. Two more? Two more questions? Me?
That's one. That's two. Thank you very much. Thank you very much to all the presenters today and all the speakers that we've seen of all such shapes, sizes, and the types of speeches. Thank you very much. Now I call upon our Professor Evans Ojo, the director of our Space Center, to give us the vote of thanks. We are also going to ask Prof to also make the closing remarks as part of his vote of thanks.
You need both goes together.
Thank
Thank you very much. Yeah, thank you. Okay, that's fine. Okay, thank you, program directors. Okay. The Chief Director, DSI, in absentia. Let me stress this. Most of the dignitaries that I'm going to be calling, they came because of maybe constraint of time, trying to catch flights. They may not be available, but in absentia, I'll just notify or just acknowledge them. Like the first person I'm going to call now, which is the Chief Director, DSTI, Mr. Utumele Makaloy. Thank you for coming. The Deputy Chief Director in Essential Space System, Mr. Kaza Moroka. CEO SAMSA in Essential, Mr. Hulubalani Modau, not present with us physically. The DVC RIE, which is represented by Prof. Ramabudu. In Essential, that's Prof. Namabola. Then the acting executive dean, Professor Sudesh Ratila, distinguished guests, all protocol observed. Greetings to everyone. Before I start, just to make some specific individual to know that I'm very specific. I'm not the kind of person that spend time to, to digress. I want to use a word that some will laugh if they hear it. Let's call it speed is speed. I know there are some certain individual that knows what that phrase represents. My name remains Professor Ivan Seshemoge Ojo, the Director of Space Science Research Center. I will stress it has been an immense gratitude and joy that I stand in front of you all to give this vote of thanks for this amazing occasion. Then they are combining with it. They said I should make it vote of thanks and the closing remarks, meaning everything I'm going to say today will combine both, should I say both items. The DSTI, the DUT DSTI 4th Space Science and CNS Symposium has been a great success. It's evidenced by us sitting here, and I'm going to be what am I going to thanks in terms of how I'm delighted to stand before everybody here today. According to the quote, only a life lived for others is a life lived worthwhile. I believe it translates to everybody here. We living for others is a worthwhile, and I believe that is one of the essence of us being here today. I must emphasize that without the effort of so many amazing people, today's event would not have been possible. It has been a long day, which we all know. We started, though due to rain and other unforeseen circumstances, we started late. But we will be very thankful that all of us have be patient, participated throughout the entire event. This, to me, deserves a round of applause. I want us to clap ourselves. Thank you for being here today. It's very, very important. First and foremost, I would like to extend my heartfelt thanks to our presenter for their inspiring words and valuable insight. I will confess the presentation today makes me to start thinking, and that's one of the things I would say is a positive characteristics. When you come to a presentation like this and it gives you that leverage to think, you should say, yes, job well done. Your presence has truly elevated this event, and we are deeply grateful for the time and the effort you have dedicated to bring here with us personally and online participation. My first heartfelt gratitude goes to Mr. Utumleng Makoloy, the Chief Director, and Mr. Kaiser Moroka, the Chief Deputy Director of Space System. They have always have their invaluable contributions and on related support to successful hosting of the annual Space Science Symposium, meaning that we are going to count on them next year to continue to support our events. Their continued support and provision of resources for the center is unparalleled. They have always thrown their support behind our initiative and made concrete commitment to support the organization and hosting of this event. This is evidence today. Though they are not here, please, I want you guys to give them a round of applause. Their support is really, really great. Thank you. I want to thank Professor Namabola, the DVC RIE, for his support. I want to also thank Professor Ratila, the outgoing Executive Dean of Faculty of Engineering and the Built Environment. I will say this, Prof. Radila, you are a leader I have had the opportunity to work with, not to work for. I don't know whether you know the difference, but I will repeat. You are a leader that I've had the opportunity to work with, not to work for. This is a real opportunity. Yes, my special thanks goes to our sponsors, NRF, SAA, STA, and our collaborators, which are the DSTI, ATNS, SANSAS, Space Tech Foundation, whose support makes this event possible. Your belief in our views, commitment, our vision, commitment to our cause is deeply appreciated. In recognition, the Department of Science, Technology and Innovation is represented in Essential, Mr. Kaza Moroka and Mr. Itumuleng Mokaloye. ATNS represented by Mr. Takalani Takalaha, may please forgive me, and Mr. Justin Whitten. Thank you for your presence. Please a round of applause for them. ASTRI UKZN represented by today. I was expected to see Professor Mike Brooks and Professor John Pitot, but I saw a new face today which I have to recognize, Mr. Jordan Silva. Thank you guys for coming. We really appreciate your presence today. Thank you. A round of applause for them, please. Today we have an opportunity of also having, though they didn't present, but their presence was well fed, which is the National Earth Observation and Space Secretarial NEOS. If you look at their stand there, it was so rich. You can take any souvenir from them because I can see that they have much to give. In essential, I have to thank Advocate Lelu Kwa Makapela and Crystal for their continuous support to this center. Thank you very much. Please, can you guys give them a round of applause? Yes, I want to recognize the SA Space Tech Foundation, being represented by their dynamic Dr. Tabani Maziboku. I was shocked today. He surprised me because last event, I was congratulating him on the first book. Today, he's making me to congratulate him on the second book. Mr. Tabani, thank you for your support. Please, a round of applause for him. Yes. As the coordinator of this center for the past approximately 3 years, my mission was focused on the concept of continuity. And this concept was finally established today with the successful hosting of the 4th Space Science and CNS Symposium. According to the quote, the more I learn, the more I realize how much I did not know. I strongly believe it is time to elevate our mission, which is to move into the next frontier of space science exploration. I believe that was the thing that was established in the presentation today. This is our next frontier. Let's move into more of space science research and, bring out some, some positive, innovation and, entrepreneur in any form from the next frontier we are going to embark on. Thus, I want to use this opportunity to thank the team whose help this mission will be realized. The staff of DSTI, DUT, Space Science Research Center. These staff were organizers and hardworking team behind the scene. I would like to express my gratitude for their implementation. Everything went without a hitch. Thank you for your commitment and meticulous attention to details, and your efforts have been acknowledged. Please, I use the word, it's not a mistake. Have been, meaning before today, has been acknowledged. Due to time constraint, I would like to quickly recognize them. Please, I'm not recognizing them in the order of importance. It's a team. A team does not have the best, nor the worst. A team is a team. Everybody is important as the other. Calling their names does not mean because your name came first, you are more important. No, please, that is not the case. Yes, the first person I'm going to recognize is Miss Nantla Mtukushe. Yes. The second person I'm going to recognize is Professor Musasa Kabea, who is also my RTHOD. I know he was here, but he has left in absentia. Please help me to recognize him for his efforts. Yes, the third person I want to recognize is Mr. Jude Lamini. Yes, very dynamic. Keep me on toes. The fourth person is Dr. Elijah Olurutimi. Yes, thank you very much. Then the another person that I will recognize is Musa Wonkosi Zulu. Yes, thank you very much for your support. The next person is Mrs. Arita Pile, ever dynamic, always there for me. Yes, thank you very much. The other one is Mrs. the person that just finished her presentation, Mrs. Nopulelo Kili. Please, thank you for your support. Yes, the next person I'm going to recognize is Dr. Untobeshle Maziboku. Thank you for your... And the next one is, I stop calling numbers because I don't want them to believe that the number is the person. No. Yes, the next person is Mr. Kulukani Untuli. Thank you for your running around. Your energy was highly recognized. Thank you very much. The next person is Miss Lubuhan P. Popapi. Thank you very much for your inspiration. The next person is Miss Sichle Mtembu. Thank you very much. Thank you. I really appreciate everything you have done. The next person is Miss Tandeka Makaya. Yes. Thank you very much. I appreciate your inspiration. The next person, not the last person, is should I say, we call her the secretariat. She connects everybody that I have mentioned earlier. She is the one that we always go to and pour our frustration on. And she's always there to make sure that we are all happy no matter what we go through. I'm going to recognize Miss Senatemba Nknobo, our secretariat. Thank you for your work and connecting everybody and making sure that we are all well taken care of. Thank you very much. At this point, my sincere gratitude goes to the department of the colleagues at the Department of Electrical Power Engineering, the Department of Electronics and Computer Engineering for your presence. Thank you. I can see that you guys are well represented here. Please, I want your continued support with regard to space science. Thank you very much. My gratitude goes to, again, because I just have to really acknowledge him. My gratitude goes to the acting Dean of the Faculty of Engineering, Prof. Sudesh Ratira. Thank you for your continuous assistance. Thank you. I really appreciate your support. Again, because of my happiness, I want to really acknowledge the presenters whose words are not enough, but that is words are not enough for me to express my commitment and appreciation, but just to tell or to say to all that presented today, thank you, and thank you. My times, yeah, I think. I wanted to give a special thanks to this next item, but because of the presentation of Mrs. Pili, I will not go into it because the presentation actually mentioned their names. If you did listen or if you did look at it, the names, the concept, and everything is there. The team I'm talking about is the student staff that are working on the Mars rover project. I don't need to go into any discussion or any naming because Ms. Pili has already done that for me. Thank you for the project and the successful, should I say, completion of phase 1 of that project. There is, thank you. There is something that caught my attention. I wanted to mention, I wanted to stress it during the first keynote speaker, but I said, no, I have to say it because with the presentation, there was something that I've always been asking. It's a practical question that I've been asking in class. And because of it was stressed today, I just want us to take it home. There's a question I normally ask my student. I said, why are you in the university? For the past 15 years, I always get one answer. And the answer is simple. I just came to university, finish my study, get a job, and build a house for my mother. That's what all of them tell me. I get a job, I build a house for my mother. Then I ask myself the question, is that what we are really going to achieve? Thank God for the first keynote speaker today. We need to change that mindset. We really need to change that mindset. I don't need to stress on it anymore, but the message was clear, and I have to really thank the keynote speaker for letting us know that we have to change that mind of wanting to be giving, but instead, let's try and see how we can give by the word. I know my master ceremony mentioned, gave him a name, Mr. Capital. Let's see how we can start making capital. Though he used one that I was so shocked. He said, my relationship with my wife is a capital. I said, how? Okay. Meaning that every relationship in this world now will be a capital. Right? Thank you very much. Special recognition goes to Mr. Kaiser Muruka for providing the resources used for this event and his unwavering support for the center. Thank you. Finally, I would like to express my gratitude to everyone who attended this event. Please, I want us to give ourselves a round of applause. We hope you have, so you leave this event feeling uplifted, which I know, enriched, because your presence has brought warmth and vitality to this event. As we conclude, let us carry forward the idea and connection we have made today. I know we have networked, we have moved around the stand. It should not end there. I believe Dr. Mazibuku will always want us to, to collaborate, because dynamism is one of them. Please, we don't need to allow all the concepts, ideas, friendship, relationship, capital we have built today to go to waste. Let's carry it forward. Once again, thank you all for making this event a huge success. Wish you a safe journey home and a wonderful day ahead. Thank you. Iyabonga Kakulu.